Hello, hello, hello. How is everybody? All good? Having fun? Okay, nobody's there yet. Who am I talking to, man? I think there has to be more efforts from our side to get your all attention to the channel. Huh? What do you think? Great. So I hope I'm audible, right? There is no audio issue. Let me just check with my phone and then we can start. Integration, guys. The topic which is feared by many and liked by a few. But I hope I'll try my best to make you like this chapter, at least make you confident in this chapter. Okay, so yeah, integration we all have been waiting from a while. If prerequisites, generally students ask me that what are the prerequisites and all, but I'll say that here the prerequisite, there is only one prerequisite, that we need brains, all of us have. Second is differentiation. Yeah, 12th class, majorly all topics, you at least need to know differentiation. No? That is why differentiation generally in JEE syllabus is taught in 11th class only, right? Okay, so now we are going to begin integration. Long chapter, definitely I'll say that it is going to be a long chapter. If we take too much time, then we'll separate it into two parts. Otherwise, today we'll try that we can cover as much as possible and as well as possible in integration. Okay, ji? So let's start. Okay, without wasting any time, let's just start with integration. Indefinite integration and definite integration. Whenever you see, like you must have seen this type of integrals also, right? Where some values are written on top and bottom of the integral. This is definite integral. Today we are going to talk about indefinite integral. First, we need to know integrals, then only definite integral and differential equations will become easy for us. So this is the basic foundation chapter for the two very major chapters, which are definite integrals as well as our differential equations, right? Integration is one of the most important topic of class 12. Even if you go through NCRT, right, students do fear this chapter. Generally, I'm not saying that you do, but yeah, this happens. Now, what all do we have? Let's see. Standard integrals, very important. The most important thing in this chapter is to by heart standard integrals. A lot of memory jog is going to be needed in this chapter. I will not deny that there is some way in which you do not have to memorize all the formulas or all the standard integrals. Without that, you cannot proceed, right? Even if you have seen the textbook of CBSE, which is the NCRT, you'll see that they have also given a list of standard integrals which you need to remember. Now, how to remember? Yeah, that can be related, but yeah, you have to remember. Just like standard differentials or standard derivatives, you remember. That's how you can remember these two. So now is the time to make a list and stick on the wall of your room for memorizing. The entire math, I won't say that it's not about memorizing. Some things to solve the questions effectively, we need to memorize. In the given time frame, if we need to solve, we have to memorize. Right? Otherwise, we cannot keep on deriving and thinking, linking and all. It's not going to be done. Second thing, very important, integration by substitution. Right? Integration by substitution is going to be needed in this chapter, which is one of the important thing in the beginning itself, which will lead you towards the other parts of this chapter. After that, important things, if we talk about the majorly from which of the portions the questions are asked, trigonometric formats, from last 2 3 years questions, if you'll see that a lot of trigonometric formats are asked. Trigonometric formats, specifically all the standard formats are very very important in this chapter. This chapter is totally about the standard formats, totally, right? Integration by substitution definitely is going to build this foundation to even apply the standard formats. So in every part of this chapter, keep connecting very well the parts which you are learning, and also I would say that try to note down the type of problems that we are solving, because standard problems are there, standard types, but too many. It's not that only two, three, just like in continuity differentiability or in limits, we have some limited standard types. Here, it's in abundance. Okay. Sorry. Okay. Partial fraction integration is going to be needed in other chapters, but solely from this part, not many questions are going to be asked. Main of parts of this chapter are substitution, integration by substitution, standard formats, and trigonometric formats. Main parts. Critically, if you see which from which of the portions the questions are asked, these are those portions. Okay. First thing, integration. What do we mean by integration? We know differentiation, right? We know dy by dx, or d of f of x by x, uh, uh, or this thing, right? We know that if we are differentiating a function f of x by x, we get a derivative. Suppose our derivative is f of x, right? Capital F I've introduced. So now integral of f of x will be small f of x plus c. That means our integration and differentiation are completely linked. And that is why if you read the definition, it simply says that integration is basically inverse process of differentiation. We also call the integrals as antiderivatives, right? So if we find dy, if we differentiate f of x and if we are getting small f of x, then if when we integrate small f of x, we'll get capital F of x. Both are linked. Now what is this c? C is a constant of integration. C is called a constant is generated when we integrate, and that is called the constant of integration. Now why is this constant there? We know that dy by dx or derivative gives us the tangent. Yeah, I'm weak. Please tell some ideas. Okay, Jina. Okay, I'll try to make it this productive for you. Great. Now, what I'm saying is that why is this C? Can somebody tell me why is, have you ever found that why is this C there? What is the significance of C? I was saying that as derivatives gives us the tangent at a point, correct? Tangent at a point on a curve. Similarly, integrals give us a family of curves, a family of tangents, sorry, a family of curves, and for every c this integral is going to change. This constant, depending on this constant, will be getting different curves. So integrals represent a family of curves, just like differential represents tangents. Okay. Small or brief reason here, you can understand that c is there for a reason. For every, when we keep changing c, we'll be getting different curves. Okay, we'll study about this in detail in the other chapters. Don't worry about it. But for now, what do we mean by integral? Integral just means antiderivative, inverse process of differentiation. A big list is in front of you, and here you can relate when I'm saying inverse process of differentiation. When we say what what will be, what will be the derivative of this x to the power n plus 1 upon n plus 1, right? You know how to find the derivative. You'll bring n plus 1 in the front, right? N plus 1 will be multiplied, x to the power will become n plus 1 minus 1, correct? X plus 1 minus 1 will give you just x only, or x to the power n only, sorry, x to the power n. And this 1 upon n plus 1 is a constant, so it will be divided. Now this n plus 1 got cancelled, and what do we have? X to the power n. So when we differentiate this, we get x to the power n. So when we will integrate x to the power n, we'll get its derivative. Everywhere you can see its connection. When you differentiate ln of x, what do you get? You get 1 by x. So when you integrate 1 by x, you'll get ln of x. And there is definitely going to be a constant added to it. So all the integrals are related to their derivatives, but this cannot be always the general way of remembering integrals. No. Yeah, you can always connect. If you thoroughly remember all the differentials, all the derivatives, then that is definitely going to help you. But that is not the suggested way. I would say that you actually remember the entire list. These are standard ones, standard integrals that you need to remember. Sometimes students do get confused in this one. Okay, they know differential is this, but in integration this is a bit different. This is a bit different. So integral of a to the power x will be a to the power x by ln of a plus c. Ln of a means natural log of a. Okay, right? This one is important. These you can remember, you know that differentiation of minus cos of x will be sin x, minus of minus sin x will become positive x, right? So integral of sin x will be minus cos x plus c. Okay, plus c every time you're supposed to put there, so that you do not forget. And you'll see in the questions what is this important, why are we adding this c, without this why the answer cannot be complete. Okay, in every question you realize that. Okay, so cos of x is equal to sin, the integral of cos of x is sin x plus c, right? These and all these things you can relate from differentials if you remember the derivatives, if you remember the standard derivatives. Okay, this one is important, right? Sec square x, the integral of sec square x is tan x. The integral of cosec square x is minus cot x plus c. Okay, these two, both of them are going to be used widely. Similarly, this one and almost all, you never know where are you going to need which one. So I won't say that which ones are most important or which ones are less important, but yeah, all of them are naturally very, very important integrals. You have to remember this list, by heart this, mug it up in your mind, write them down on a paper neatly and paste it on the wall of your room. If you are in class 11 right now, do it even now itself, not a problem. You must be using basic integrals in your physics classes. So this is going to help you, this is going to help you more. Better you mug it up, faster you mug it up, healthier it will be for your performance, definitely. Okay, so do not just take them lightly, you have to mug them up. Okay, now over here also, some of them, sine inverse x, integral sorry, differential will be like this, 1 by root x. Here, you know all of, and even for remembering you can take some hints. For example, a square minus x square, sine inverse x will be the sine inverse x by a will be the integral of 1 by square root a square minus x square. Similarly, cos inverse x by a will be the integral of minus 1 by square root a square minus x square. So this is written in such a way that you can link and remember. But yeah, you'll have to remember all of them. Very important to remember them. Without this slide, you cannot even proceed to the questions ahead. That I can say. So if you're watching it in a recording also, pause it, write them down, and keep that page in front of you while proceeding ahead in the chapter. Otherwise, you'll keep getting confused. Okay, not a problem. The list is not over yet. Okay, list is not over yet. There is more. But yeah, once or twice you'll write them down. You can see the link. You can see the link, right? This is sec square 1 by a sec square x by a, and this is 1 by a cosec square cosec inverse x by a. Here sec inverse x by a, and here cosec inverse x by a. Here minus 1, here plus 1. So you'll remember. It'll not be that difficult for you to remember. You guys can remember a lot of things in your inorganic chemistry. In entire periodic table you guys remember. So this is not going to be a trouble for you all. Okay. Now, so all of these, there are going to be some standard, more of them. Now, in this chapter, the most important thing or most important part is that everything is connected. Everything is connected. One concept, the last of the concept, when we'll go to the by parts or partial fractions or algebraic formats also, you'll see that the starting concepts are being used. So you learn it in a very thorough way. Generally, students don't like integration because they study it in parts or they study it randomly. No, whenever you are studying integration, you study it from right from the start. Even if you're revising, revise it right from the start. Then you'll get grip over it. Trust me, that is a suggested way. Okay. Now, yeah, great thing. See, sometimes in options, options also integration, there is a reason they call integration as one of the trickiest chapter of class 12. Reason is that here a lot of connectivity is found. A lot of connectivity is being found. Okay, just like in functions, functions also don't have as much of connectivity as integration. Okay, so why is this written? I'll tell you. This is written because sometimes in options you'll get this as your answer. You know that the integral of sec x is ln of sec x plus tan x, but in the options you'll see these things. So you should be able to match that. How are they related? Okay, this one you can understand very well. Because that sec x plus tan x, this thing sec x plus tan x can be written as 1 sec x minus tan x. Right? From basics of trigonometry, you know that this can be done. Or otherwise, you just multiply these two. This is sec square minus tan x, tan square, which is 1. Okay. So now in option, maybe you don't have this, but you have this one. Right? So ln of 1 by sec x minus tan x will be minus ln of sec x minus tan x. Correct? So you'll mark this. Maybe you don't see this, but you see this. So you should be able to easily relate. Acha, this is that. Similarly, this one also is related. Ln of sec x plus tan x can also be written as ln of tan pi by 4 plus x by 2. Would you like to try how? 1 by cos plus sin by cos. That means 1 plus sin x by cos. 1 plus sin x by cos x. Correct? 1 plus sin x by cos x. Now just write it in half angle formula. Write it in the form of half angle formulas. What will this become? 1 plus sin x. When we see 1 plus sin x or 1 plus sin 2x, what comes in your mind? What should come in our mind? Sin x plus cos x whole square. Right? That will be 1 plus sin 2x. So here 1 plus sin x is there. So what should we write? Cos of x by 2. We can write it like this. Cos of x by 2 plus sin of x by 2 whole square. Won't this be the numerator? And cos x can be written as cos square x by 2 minus sin square x by 2. Cos x by 2 plus sin x by 2 into cos x by 2 minus sin x by 2. So what will remain with? Will just remain with cos of x by 2 plus sin of x by 2 divided by cos of x by 2 minus sin, oh sorry, plus, yeah, minus sin of x by 2. Now divided by cos of x by 2. Divided by cos of x by 2, what will you get? 1 plus tan of x by 2, 1 minus tan of x by 2. Correct? 1 plus tan of x by 2 upon 1 minus tan of x by 2 is just this. 1 plus tan x by 2, sorry, upon 1 minus tan of x by 2. These are same. Correct? Isn't it same thing written? This is the same thing written, yes or no? Correct? So sometimes it's possible that this is there in the options. So this also, with practice, don't worry. With practice, if you practice a lot, integration requires a lot of practice. If you practice a lot, this thing will come into your observation at least for 3-4 times. And when it does, you'll be able to remember it. Don't worry about it. Okay. Just a minute. So if you want to note it down, or I'll provide you the notes anyway later. Similarly 2, this can be written as 1 by cosec x plus cot x. So minus ln of cosec x plus cot x. Here also, if you convert into half angles, you'll get the same thing, ln of x by 2 plus c. these two things you must just note down somewhere as important, because in options you might be seeing these forms of this thing. Integral you will remember, but you also need only these two. For now, I'm saying this is going to be important. Okay, great. Let's move ahead. Now, just like in differentiation, we can differentiate over. Now, see, in differentiation, we have a lot of generalization. We have product rule, we have chain rule, right? And we generalize things also. If we know the differential or a derivative of one thing, then we can generalize it for a format or something. But here we won't do that. Integration is very, very specific with formats, with standard integrals. You do not generalize things over here. Very good, DK Dragon. Okay, this thing is definitely for sure. If you have a constant multiplied with the function, you can take that constant out. If you have plus or minus between two functions and integrating it, you can integrate them separately, not a problem. This is quite same here. Okay, all right. Next thing, let's do some questions now. I think it's time for some questions. Try to do them. Try to once attempt them. Now see, obviously you are not going to be asked what is the integral of this standard integral. The list which you saw, directly same questions you are not going to get. Same questions you are not going to get. Okay. What you need to do in the entire chapter, try to convert or try to deduce or derive your given format into the standard format. You'll not be given the standard format, the list which we saw in the starting. So you'll have to convert them into the standard format. That is the main uh, key point, or you can say challenge. Okay, all right. Now first one, okay, directly, wait, let's solve them. For example, if we look at the a part is sec square by cosec square, so 1 by cos square upon 1 by sine square. So what do we have over here? This is just tan square x dx. Can we say that? Now, do we know tan square x integral? Let's check the list. We don't actually. Okay, we don't have tan square x integral. In the standard list, it's not there. What do we have? We have sec square. We have sec square x. Correct? We have sec square x. So, don't just directly randomly do things. Okay, tan square x, if you don't know, you don't know. You'll have to convert it into something which you know. Standard thing. Okay, now this is going to be integral of, so what we can write over here, sec square x minus 1 dx, and this can be broken, so this will be integral of sec square x minus integral of dx, or 1 dx. Wait, here also, okay, this is something we can do. Now we know the integral. This is nothing but tan x. Okay, what is the integral of 1 into x to the power 0? X to the power 0 integral will be x to the power n ka integral is x to the power n plus 1 upon n plus 1. X to the power 0's integral will be x to the power 1 upon 1. That means just x, right? So x, tan x minus x plus c. Do not forget your plus c over here. Okay. Try to do the second one. Give it a chance. Second one. Just give it a thought in your mind. What, I want to get good rank in JEE, but I'm scared of maths. But if you're scared of maths, just do a lot of maths. Okay, whenever you get scared of dark or anything. I used to get scared of noises, these firecrackers. Like I spent somewhere around 8 or 9 Diwalis. My father used to burst the firecrackers like in abundance. He used to do it a lot. And I used to spend my Diwalis in a corner, just closing my ears, crying badly because I was so scared of the crackers. those bombs and those sounds. So how did I get rid of it? I just faced it. Once my elder brother just took me in front of these crackers, he started bursting all of them. I had to hear them. That was the only way. Otherwise, even till now, even till this age, I could not get rid of that fear. Getting rid of fear, the only method of getting rid of any fear, I'm just talking about this example, but any fear, you do that. You face it. I know you must have heard this line a lot of times, but this is the only way actually. There is no other way. You're scared of water, jump into water. Hey, don't do that. But yeah, that is the only way. Okay, that actually is the only way. All right. Next thing, cos x minus cos of 2x. What do you do when you see cos of 2x? What do you do when you see cos of 2x? Can you write it as 2 cos square x minus 1? Right? We know we have if you have watched the lecture of trigonometry, whenever you see sine 2x, you write 1 plus 2 1 plus cos 2 1 plus sine 1 plus cos square x 2 cos square x. When you see cos 2x, what do? 2 cos square x minus 1. So here just build it, because see, when you're seeing 1 minus cos x, that means this cos 2x you want to get rid of. So simply just write cos x minus 2 cos square x minus 1 upon 1 minus cos x. Now just check, have you got the rate? This will become 2 cos square x minus cos x plus 1. Okay, this will become 2 cos square x minus cos x plus 1 upon 1 minus cos x. What can you do about it? Just let it remain like this, 1 minus cos x, not a problem. Now this thing, what can you do about this thing? This is a simple quadratic. Can you factorize it? 2x square minus x plus 1. Simple thing, right? So what can you do about it? You can write it as 2 cos x plus 1 into cos x minus 1 upon 1 minus cos x you already have. So cancel this. This will become minus 1. So what will we have? We'll have integral of minus 2 cos x minus integral of 1. Dx is there, dx is there. What will this become? This will become 2 sin x. Okay, minus minus will become plus. So this will become 2 sin x. This will become plus x. Oh, wait. 2 cos x minus 1. Yeah, correct, correct, correct. Huh. 2 sin x minus x plus c. This will become 2 sin x minus x plus c. Not a problem. Okay. Third one, the hint I already gave you. There is a hint which I already gave you. You see 1 minus cos 2x. What is 1 minus cos 2x? Sine square x. Right? Simply sine square x. If you'll write it, you'll get your answer. This will just become integral of this. This thing is 1 minus cos 2x can be written as sine square x. Now you know this integral you don't know, but you know cosec square x. So 1 by sine square x will become cosec square x dx. This integral you know. Uh, wait. 1 by 2 sine square x it will become, no? Wait. 2 sine square x. So 1 by 2 sine square x it will become. Here also 1 by 2 will come. This will become 1 by 2, and cosec square x integral we know as minus cot of x plus c. Directly you can write. So now you must have realized how much important is your first list over here. This list which was shown in the starting. That is definitely very, very important. That list is going to play the major role in the entire chapter. Do not avoid it. Okay. Shall we move ahead? I hope. See, take time, solve along with me, solve slowly, but solve. Okay, keep solving. keep writing in your, if you're studying for this for the first time, and if you're watching the recording also later on, please solve along with me. There is no shame in that, there is no problem in that, it should be done. Okay, this is A. I hope we found all the answers correctly. Hey, we are getting plus over here. How? We got cos of x minus 1 only, na? Acha, no, 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 no. This was 1 minus cos x only. Yes, 1 minus cos x only. So this will become plus. This will become plus. Sorry, my bad. Okay, solutions are there, but try to solve on your own. Now, some algebraic, we saw till now we are not doing any formats. This is just, we are just trying to convert the given shape into the shape that we know. That means the given picture into the picture that we know from the starting list, from the standard integrals. Okay, we will try to convert everything that we can to standard integrals, even if we are, even after even after trying, if we are not able to convert, that means then we'll have to look for the other formats, that means algebraic formats or by parts or other things. But these type of pictures are going to be okay with you, so don't fear them. X to the power 4 by x square plus 1, can you do something about it? But if you want to, if you obviously you can convert it. There are only few algebraic formats, x to the power n, something like x to the power n. You'll have to convert it, or you have to write it into different parts. Correct. Now, what is bothering you? X to the power 4. No, x to the power 4 numerator, you want to cancel. The first feeling which should come in your mind is that I want to cancel. I want to get rid of this x square plus 1. If I have only the numerator, then I can just separate the integrals plus minus and I'll apply standard integral over there. So how do you get rid of x square plus 1? You see x to the power 4 over there. Now, if you add 1 and subtract 1 in x to the power 4, will it affect? No. But how will it change your thing? How can you cancel now? Something will happen which will cancel this x square plus 1. Yes or no? Are you getting that feeling? So now, if you want to cancel, you'll need to create x square plus 1 and x square minus 1 factors, something like that. Now, for creating that, you'll have to club this minus 1 with x to the power 4. So instead of this, we should write x to the power 4 minus 1 plus 1. Correct? Can we do this? Now, okay. Now, did it help you? What will be the factors over here? What will be the factors over here? X square minus 1 into x square plus 1. Right? This will become x square minus 1 into x square plus 1. X to the power 4 minus 1 square. So this will become x square minus 1 into x square plus 1. Okay. Divided by x square plus 1. And yeah, obviously this plus 1 is still there. But now something has changed. Now we can break it. Now we know if we break the factors, one of them will get is x square plus 1 and x square plus 1 will get cancelled. So one of them will be x square minus 1 dx plus integral of 1 dx. Now we can solve. This we know. This will become integral of x square dx minus integral of 1 dx plus integral of 1 dx. Oh, sorry. This, instead of this, we'll have 1 by x square plus 1. Integral of 1 by x square plus 1. These are all standard integrals. Correct or not? Let me check. Do we have a slide after this? Yeah. These are all standard integrals. X square will become x cube by 3. Minus 1 will become minus x. And this one is the integral of integral of this is tan inverse of x. This is tan inverse of x. I'll show you the picture once again, just for the reference. Look, 1 by a into tan inverse of x by a. A is 1 over there, right? A is 1 over there, so 1 by 1 will become 1 only. This is tan inverse of x. So with the practice, you will be able to actually remember these formula. No need to worry about it. With practice, you will be able to apply them very easily, very efficiently. There is no need to worry about it. Hi Jason, how are you? Did we solve this one? No, we didn't solve this one, right? Okay. We don't have space. X to the power 6 plus 1 upon x square plus 1. X to the power 6 plus 1 upon x square plus 1. Integral of this. Again, you can get rid of this x square plus 1. How will you get rid of it? Try to do it on your own once. Right? You'll write this one as x cube plus 1 cube, like a cube plus b cube format. So what will you do? This you'll write as x square whole cube plus 1 cube or 1, and this one is x square plus. Now this will become nothing but a cube plus b cube. So x square plus 1, 1 factor a cube plus b cube is a plus b into a square plus b square minus ab, right? So this will become x to the power 4 plus 1 minus x square upon x square plus 1, okay, dx. This will get cancelled. What do you have now? You have x to the power 4 minus x square plus 1 dx. This this will become x to the power 5 by 5 plus x, sorry, minus x cube by 3 plus x plus c. This will be your answer. Okay, move ahead. Achha, one more part is there, kya? Wait, yeah, x to the power 6 minus, this you can do now, right? Same thing, B and C are same. This you can do on your own. This part, you'll be able to try this now itself. I'll give you a minute. Here also x square plus 1 will get cancelled. What will you remain with? X to the power 4 minus x square plus 1, right? Only x to the power 4 minus x square plus 1 will remain. Try this once on your own. Okay. So to create, you need x square plus 1 over here. So you need x cube minus 1. So x square cube minus 1. But minus 1 won't work like this, right? You need plus 1, right? You need plus 1. Then only x square plus 1 will come out. So if you want plus 1, you'll just take plus 1 and subtract 2. Correct? This you can do. Not a problem. This will become x square plus 1 into x to the power 4 plus x square minus 1. So plus 1 minus x square minus 2 upon x square plus 1. You can integrate later. Correct? This will become x square plus 1 into x to the power 4 plus 1 minus x square divided by x square plus 1 minus 2 by x square plus 1. And you can integrate it. This will get cancelled. This you know, this you know. 2 by this one, 2 by x square plus 1. That means 2 tan inverse of x. 2 tan inverse of x. A is 1 only over here also. So your final answer will become x to the power 5 by 5 plus minus x cube by 3 plus x plus minus. Here also minus 2 tan inverse of x plus c. Just separate it. For the c part. Okay. Which 2 is eliminated? How 2 is eliminated? Which 2 are you talking about, Mohit? Mohan. Which 2 you got eliminated? No 2 I eliminated, beta. This 2 tan inverse, this is 2. I didn't eliminate 2. I wrote it separately. I hope you are able to view. My bad handwriting is affecting kya? Can't help it. Now, yeah, this is very important. Okay, this is actually very important. How do I? Okay, let's see a question and see if we can understand this. Huh. Let's look at this. Now, see, like in differentiation, what do? We apply chain rule over here, right? We'll differentiate it and then differentiate the inner function. Outer function, then inner function. In integration, we cannot do anything like that because things are not generalized in integration. Here, there is a standard method which we have to use. Whenever you see something like this, something which is not in the standard form, but the inner function is inside the standard form of something. We know sine x. We know sine integral of sine x. We don't know the integral of 2x plus 1. Sorry, sine of 2x plus 1. So in this case, what do? We write 2x plus 1 is equal to some t. We'll substitute. Here, the substitution has already started. So this is the first part of it. Okay, this is the very first hint of substitution. How do you use substitution? You have to substitute things to get the standard formats in integration. So here what will we substitute? Here we'll substitute 2x plus 1 as t. Now when we'll do it, now differentiate on both the sides. Okay, now differentiate on both the sides. So what do we get? We get 2 dx is equal to dt. Right, we'll get 2 dx is equal to dt. So what did your dx become? Dx became dt divided by 2. Now look at this. Integral of sine of 2x plus 1 into dx dot dx. Now what is your dx? dt by 2. What is your t? 2x plus 1. So this just became sine of t, right? And dx became dt by 2. We cannot integrate with dx. We have t over here, so we need t only. So we'll write this as dt by 2. And this 2 will come outside and it will become 1 by 2 sine of t dt. This we know, right? This we know. Minus cos x. Minus cos t it will become. So 1 by 2 minus 1 by 2 cos of t. What is t again? T is nothing but this only, cos of 2x plus 1. Correct? I'm just showing you this example prior to explain you what came before. Okay? What came before. Now here you observe one thing. You knew the integral of sine x, which is minus cos x, right? So you can put minus cos. What came as your answer? What came as your answer? Minus cos of 2x plus 1 divided by 2. What is this 2? This 2 is nothing but the coefficient of x. So relating this over here is very, very important. I'll go back to the previous thing now. What is this saying? That if you know the integral of f of x, if you know the integral of f of x, which is, let's say, some function, okay, the integral of small f of x is f of capital F of x, then you can also simply write the integral of f of ax plus b. Right? If instead of x we write ax plus b, that means some linear format. In that case, what you need to just do, you need to same integral will come, right? In this f of x, ax plus b will come. Instead of capital F of x, we'll have capital F of ax plus b, and we'll divide that integral by the coefficient of x. We'll divide that integral by the coefficient of x. Nothing new, nothing major. Okay, so that's what we did, right? If we go back to that, we knew the integral cos of 2x plus 1 divided by 2 minus cos of 2x plus 1 divided by 2. That's how we write. Same, sine of x integral will be minus cos of x. Sine of 2x plus 1 integral will be minus cos of 2x plus 1, and we'll divide by the coefficient of x, which is 2. That's it. Now see this one. We do not know the integral of tan 2x or tan 3x. What do we know? We know the integral of tan x. Correct. And just like in differentiation, we cannot generalize over here also. We cannot do that. We cannot generalize that, okay, tan x, we know we chain rule or a product rule, we cannot do like that. Integration is very specific, so we have to learn, understand the standard formats. Tan x, tan 2x, tan 3x we have. Okay, first thing that we know, if you remember, if your A is equal to B plus C, or if your C is equal to A plus B, then tan A, tan B, tan C will become tan C minus tan B minus tan A. Starting from the greatest one, greater, smallest. Okay. Integration is not difficult, beta. It just requires rigorous practice. And before this, I would suggest complete your differentials and trigonometry. Two things are very much important. Differentiation should be strong, and trigonometry, basic trigonometry, should be strong over here. Okay. So this thing, you know. Now, what will be the integration of tan x? You know the integration of tan x. Do you know the integration? Can you find the integration of tan 2x now over here? Tan x integral, you know, right? From the list, if you have the list, you'll easily be able to see ln of sec x is the integral of tan x plus c. Okay. Integral of tan 2x, what will this become? Now no need to put t and all. You can put 2x is equal to t, then 2 dx will become dt and all that. But here directly, this is ax plus b form. So you'll write the same ln of sec 2x, and you'll just divide this with 2. That's it. 1 by 2. Right? Multiplied with 1 by 2 or divided by 2, same thing. Tan of 3x, what will this become? This will become 1 by 3 ln of sec 3x. Correct? Any problem in this? Now you can find. Now using this, you can write this. So this entire thing will become tan of 3x minus tan of 2x minus tan of x. And you have the integrals already. So this is how you'll have to relate things. And one thing is going to be standard formats, standard integrals, which we learned in the starting. Those are definitely very important. By now, you must have realized that we are going to use them everywhere. So make that list and stick it on the walls of your room. This one we already did. I hope you can understand what was the logic behind it. Even here you can prove. Even here you can prove. Just take ax plus b as t, and you'll be able to prove this very easily. If you take ax plus b as t, so a dx will become equal to dt, right? So dx will be dt by t, correct? Dx will become dt by t. Now dx, if dx becomes dt by t, I'll just write it. Suppose if you take ax plus b equal to t, okay, some t. So differentiate it both the sides. What will you have? A dx is equal to dt. So your dx is nothing but dt by t, right? So this entire integral will become f of t dt by, sorry, dt by a it will become, not dt by t, dt by a, right? Dt by a. This a will come out and we'll have 1 by a integral of f of t dt. Correct? Same thing that we are getting. What is f of t? F of t will be integration of f of ax plus b, because t is ax plus b. Okay. Now let's practice this thing. Okay. Over here it looks complex. If we go into solving and taking LCM and all that, if we try to convert into any other format, no need for all that. Directly you'll be able to write the answer. Do you know the integral of 2x plus 3 to the power 5? You don't know the integral of 2x plus 3 to the power 5, but you know the integral of x to the power 5. Correct? You know the integral of x to the power 5. So this can be written just like this: 2x plus 3 to the power 5 plus integral of 7x. Sometimes I'm forgetting to put dx because of lack of space. So you just assume that it's there. 7x minus 5 to the power 3. This is just like x to the power 5 integral. But instead of x, we have 2x plus 3. So x to the power 5 integral will be x to the power 6 by 6. So this will become 2x plus 3 to the power 6 by 6. Right? And we have to also divide by the coefficient of x. So 1 by 2 will be divided. 1 multiplied, or 2 will be divided. 1 by 2 will be multiplied. Here 1 by 7 will be multiplied. Do we know the integral of 1 by x to the power 3? X to the power minus 3. X to the power minus 3 will become x to the power minus 3 plus 1. That means x to the power minus 2 upon minus 2. So this will be same thing only. 1 upon 7x minus 5 to the power minus, or to the power 2 over here, upon minus 2. So that will be multiplied. Minus of 1 by 2. That will be multiplied over. Okay. This is how you should be able to write directly. Directly you should be able to write. 1 by 2 multiplied 1 by 7, because coefficient of x is 7. So 1 by 7 we are multiplying, and this 1 by 2 because of x to the power minus 3 integral. X to the power minus 3 will be x to the power minus 2 upon minus 2. That's it. Directly you will be able to write. Otherwise, see, you'll have to do this much. Put t in school exams, in your board exams, do not apply direct method. There you are supposed to do all this. If this comes in your school exam or board exam, in that case, don't apply, don't directly just write. If it is 3 marks or 5 marks question, you have to do all this. Otherwise, it's okay, not a problem. So to be able to solve faster, look at this question. Sine of x upon sine of x minus a. Is this in standard format? Any standard format do you know about this? No. What is the problem? This sine of x minus a in the denominator is the problem. Correct? So sine of x, can you write this sine of x in terms of sine of x minus a, something like this? Can you write like this? Is it a problem? If I write sine of, I want x minus a in the numerator also. So I'll create it, x minus a plus a. Is that a problem? Right? This in one bracket and this in one bracket. Divided by sine of x minus a dx. Sine a cos b, sine a plus b I can apply. Sine a cos b plus cos a sine b. So I'll write this sine of x minus a cos of a plus cos of x minus a sine of divided by. Now, did I get rid of sine of x minus a? Am I going to get rid of sine of x minus a? Definitely yes. See, in first one, I'll split this. What will this become? This and this will get cancelled. Only cos a will remain in the first part. Plus over here, tan of x minus a into sine a will remain. Not tan of x minus a into sine a will remain. No, sorry. Something is wrong. This is wrong. Cos by sine. No, so cot of x minus a into sine a. Now, you see, what are we differentiating with, what are we integrating with respect to? We are integrating by x for x. Correct? Here everywhere dx is there. So if dx is there, do you agree that sine a is going to be a constant? Constant comes out, not a problem. Cos a integral, we know cos a also a constant. So cos a will come out and we'll have x cos a over here. Because 1 dx integral will become x. Cos a is a constant, it will come out x cos a, this thing will become. What will become? What will become for cot of x minus a? What will become for cot of x minus a? cot of x minus a, integral is ln of sine x minus a, right? Ln of sine x minus a, sine a will come out, this sine a will come out, right? And integral of cot of x minus, cot of x is ln of sine x. So this will become minus nahi, some all correct. Acha, minus will come out no here also, minus ln of, so minus will come out here also, ln of sine of x minus a, but here the coefficient of x is 1 only, so 1 by 1 there is no need to write, although we need to multiply with coefficient 1 upon coefficient of x, or we need to divide with coefficient of x, but here coefficient of x is 1 only, so there is no need to divide that. Okay, there is no problem in that. Check it out. Sine a is a constant, that's why I've taken it out. Sine a is a constant. Integration of, note this down, integration of cot x is ln of sin x. So ln of sin x minus a divided by 1. No need to write that. Okay. So trigonometric questions, you need to know the formulas. There is importance of trigonometry also. There is some sound issue here. Just let me check. Just a minute. Hello, hello. Now it's coming. Now it must be okay. Now it must be okay. X cos A. Acha, plus C I am forgetting to put, but you assume that it is there. Okay. And in any of the exams, any of the subjective exams, do not forget plus C, otherwise they'll deduct your marks. In objective questions in JEE or mains or advanced, there it's okay. You'll get the feel of C in the question itself. It will be mentioned. We'll see some PYQs also. Don't worry about that. Okay, let's see this one. Now see, substitution has started. Okay, general formula based questions we cannot keep on doing because they won't be there. They are only in the NCERT level. Now more things will be substitution based. You have to know what to substitute. Now see, very important point or very important thing which you can notice over here. Generally these type of things you'll be able to see. Now whenever you see the integral of something, oh sorry, differential of something in numerator or denominator, you put that, you substitute that as t. Okay, you must understand that whenever you are seeing the, wait, I'll explain this somewhere else. So first format was that if you know the integral of x dx, then you also know the integral of ax plus b, f of x dx, then you know the integral of f of ax plus d dx. Now second thing in substitution is that in integration, suppose there is a term in the question of integration, if there is a term whose integral is there with whose differential, whose derivative is there with dx. I'll repeat again, maybe I confused you. I'm saying that in any question of integration, if you see that there is a term and the derivative of that term is with dx in the numerator, or right, obviously dx will be in the numerator only. So if you see a term in denominator or somewhere in the numerator also sometimes, and its derivative is sitting with dx, its derivative is also there in the same problem or in the same entire thing, obviously the question will have different terms and if any of those terms derivative is there with dx, then you take the general strategy should be you take that term as t. Okay, I'll explain you with this question. Okay, for example, over here, now see, x cube is there. Okay, x cube is there, x square is there, and here x to the power 6 is there. Now can you see any term whose derivative is also over here only? Can you see any term? Tan inverse x cube is there. Okay, tan inverse x cube is there. Now you, what I'm saying, here also x cube is there, x square cube or x cube whole square. 1 plus x to the power 6 is x cube whole square, right? So x cube derivative is 3x square. Don't worry about the constant, x square, 3x square. In 3x square, x square is coming, and x square is also there with dx. X square dx is also there. So general strategy should be that, for example, over here I'll write this in these terms: tan inverse of x cube divided by 1 plus x cube whole square. Now x cube is here also, and derivative of x cube, which is 3x square, that means x square is here also, and 3 will divide. No worries. Okay, 3 will divide. So our strategy should be that put this x cube as t, substitute this x cube as t. Sometimes students face difficulty in just understanding what to substitute. So those things, that how to substitute, what to substitute, how to think of substitution. Main game is of substitution only in entire integration or standard formats, but substitution is going to be needed. So we'll keep understanding how to know when to substitute what. Okay, so here x cube will be substituted. X cube will be substituted as t. We'll take x cube equal to t. So what do we get? 3x square dx differentiated on both the sides will be equal to dt. 3x square dx will be equal to dt. So your dx will become, or what will your dx become? Dx will become dt by 3x square. Or you can say x square dx will become dt. However you want to use it. X square dx became dt. Now what does this entire problem become? How did the substitution help us? So now what are we going to write? X square dx will become tan inverse x cube, tan inverse t, tan inverse t, and x square dx became dt by 3. X square dx became dt by 3. So dt over here and 3 outside because it's a constant. What did this become? 1 by x cube square, that means 1 plus x cube square, that means 1 plus t square. Okay, problem reduced, problem got easier now. Do we know the general format, any standard format over here? Tan inverse t upon 1 plus t square? No, I don't think so. So again, what do you need to think? Which, so now t square in t, the derivative of t square will be 2t, which is sitting with tan inverse, correct? So again substitute something else. 1 plus t square is, let's say, equal to some u. Now what do we have? 2t dx, 2t dt, 2t dt will be equal to du. Okay, what did dt become? What did dt become? Where did t go? Not a problem. What did dt become? Now pay attention, try to solve ahead of it. What is my dt now? Dt is du by 2t, correct? Du by 2t. What is this? Tan inverse t dt. I already have tan inverse t dt. Sorry, just a minute. Is it helping us? Can we solve ahead of it? Try to understand the substitution. No, it is not helping us, because see, yes, that is correct, that differential or derivative of t square is sitting over here, but we are taking 1 plus t square, right? That also can be accepted, that t is sitting, but t is sitting inside tan inverse. So in these type of situations, one thing you need to understand is that not inside some function. Now see, what if we take tan inverse t itself as some other substitution? Let's say tan inverse t itself at some u. You understood why we cannot take 1 plus t square as u? Because when we are taking it, it's not helping us. We still have tan inverse t. We'll still have to solve it further. But tan inverse t, what is the differential of, what is the derivative of tan inverse of t? 1 by 1 plus t square. Correct? Derivative of tan inverse of t will become 1 by 1 plus t square dt equal to du. Directly we are getting this entire thing, this entire thing, this entire thing we are getting over here. So this will become du, u du. That's it. This will just become, this entire thing will become 1 by 3 into integration of u, which we substituted, and this is just du, u du, and we know how to integrate it. We know 1 by 3, it will become u square by 2, right? Now substitute back again. What is u? Tan inverse of t. So it will become 1 by 3 tan inverse of t square by 2. Again, we want our answer in x. So t also will be substituted. T also is going to be substituted. Okay. So this will become, we can write ahead 1 by 6 into tan inverse of t. That means tan inverse of x cube. Tan inverse of x cube by, okay, 2 we have already. This is going to be our final answer, plus c. Do not forget. Any other method, if you can think of, if you want to, if this one is one just method, you can do other substitutions also. It's not necessary that this is standard. This is how only you'll have to solve. This is how only you have to substitute. Here, one more thing which you can do is tan inverse of x cube. Directly substitute as t. Your answer will come faster. Try. I'll write over here. Try tan inverse of x cube as t. So this is like strategical chapter. Here you'll have to see, here in substitution you'll have to think, what should I substitute that is going to help my problem. Here we substituted 1 plus t square, it was not helping our problem. Then we realized, okay, tan inverse t ka derivative itself is written over here, 1 by 1 plus t square will come. So that's how you can connect. Okay. So suppose if you take tan inverse of x cube as t, so 1 by x cube whole square, that means 1 by 1 plus x to the power 6 will directly come. Derivative of tan inverse of x cube will be 1 by 1 plus x cube. 1 by 1 plus x to the power 6 and then 3x square. Right? What will be the derivative of this? 1 by 1 plus x cube square multiplied with chain rule. Derivative we are finding. So 3x square. 3x square dx will be equal to dt. Directly we are getting. So we can divide. X square dx is also there. X square dx divided by 1 plus x to the power 6 is directly coming. So this will become t by, 1 by 3 into t dt. This entire thing will become 1 by 3 into of t dt. So simpler answer. That also you can do. So it depends on you, how you are substituting. But one hint is that if you have to look for derivative of a term, that you should put as t. Okay, that's the general strategy behind it. Let's look at some more problems. Okay, this one. Here, think what should we put, what should we substitute? Take a minute and think what should we substitute. We have x e to the power x. General hint, direct hint we have x e to the power x, right? If you differentiate it, if you differentiate it, if you put this, what do we get when we differentiate x into e to the power x? X into e to the power x, product rule, right? E to the power x minus x, sorry, plus x into e to the power x. Differential of this into this as it is, plus differential of this into this as it is. So differential of e to the power x will remain e to the power x only, right, multiplied with x, plus differential of x, which is 1, multiplied with e to the power x. This is the differential. So what do? We take x e to the power x equal to t, because its differential is sitting in the numerator. Correct? What will happen? Now we'll have x e to the power x plus e to the power x dx is equal to dt. So this entire problem became x e to the, this we took as t, correct? This into dx is dt. So we'll just write dt over here, because this into dx will become dt, right? So dt over here, and denominator cos square of t. That means this became sec square of t dt. This is standard integral. You know this, tan t, sec square of t will become tan t. So we'll have tan t plus c, that means tan of x e to the power x plus c. Remember, there are no generalizations in integration, no product rule, chain rule. We'll have to solve with substitution only, or standard formats, which will be learning further. Okay, remember this, these basic things. This one, what should you substitute over here? Try to think. Take a second and think, what should you substitute? Acha, in whenever, okay, here I can give you one hint. Whenever you see ln something, simple format, not standard formats which we are learning for, which are going to come upwards afterwards, but generally if you have ln in integral, no, take that as t. Without even thinking, take that as t. For example, over here I can simply take ln of x by x plus 1. This thing I have, so I'll take this as t. Why? Because see, t square dt will be created, at least t square is there, and x into x plus 1 I have. When I'll integrate this, when I'll differentiate it, if you are thorough with the differentials, just try to think of its derivative. First of all, 1 by x, ln of x, that means 1 by x. So this will become 1 by x. So 1 by this thing. So it will become x plus 1 divided by x, multiplied with differentiation of this, division rule, correct? Quotient rule, not division rule, quotient rule here we'll have to apply. So this thing, x plus 1 whole square, will come in the denominator. U by v, right? We have done this in the differentials chapter. X plus 1 whole square will be in the denominator. Then this into differentiation of this. That means x minus x plus 1 as it is. Right? U into v dash minus v into u dash. So x minus x plus 1 will come over here. Okay, equal to this into dx to dt. One x plus 1 is going over here. Okay, x minus x became 0. 1 by x into x plus 1, that is going to remain. Minus 1, actually, minus 1. So this problem will become, okay, this thing first let me write, minus 1 upon x plus 1. Minus 1 upon x into x plus 1. That will remain. Or here dx equal to dt. Now look at the problem again. Did it help us? That's why, without even thinking, put this term. Most of 99% of the times, your substitution will be helpful. If not, then think again. Okay, if not, then think again. So this is what you should do. Now what will this become? Our integral will become integral of ln, this we have put as t, so t square over here. Okay, and this dx will become dt into this, or directly we can put, right, minus of dx upon this is equal to dt. So minus will take out and dt directly can come. Minus of t square dt. It will become minus of t cube by 3 plus c. So minus of, what did we take t as? Minus of ln of x by x plus 1 cube by 3 plus c will be our final answer. Okay. Substitutions are going to play the major role in the entire chapter. What happened over here? Yeah, this only came as our answer, right? Great. Now, this is not a question, this is a format, or this is a particular type of question or term or expression, I should say, which is seen very popularly or very frequently in the questions. So here students tend to think that what should we substitute as? Here I would say, what else is there to substitute other than x plus root of x plus 1? Is there anything else to substitute? There is nothing else to substitute over here. Correct? There is nothing else to substitute over here. So we don't have any other option, right? There is only one option to substitute. What will we substitute? We'll just put this entire expression, that means x plus root of x square plus 1 as t, and we'll differentiate. So when you'll differentiate it, what will this become? I'll write directly. This will become root of x square plus 1 plus x plus x divided by root of x square plus 1. Yeah, this thing will come. This into dx will be your dt. Check once. Try to differentiate it once on your own also. Now, towards our problem. This thing we have taken as t, right? So 1 by t to the power n, integral of 1 by t to the power n, this entire thing we have taken as t. What will dx become? Dx will become this divided by this into dt. So we'll have root of x square plus 1 divided by root of x square plus 1 plus x into dt. Right? Now, still we cannot integrate it because everything we need in terms of t. So how will we get everything in terms of t? See, this thing is not a problem. This thing is already t. This thing we have taken as t. Okay, so this will just become 1 by t to the power n into, here t will come. Here definitely t is going to come. What about this? Can we write t minus x? No. What about this? So here, what do? You use one concept that, no, right? In surds and their reciprocals are generally related. So if your x plus root of x square plus 1 is equal to t, definitely your x minus root of x square plus 1 will be equal to 1 by t. Correct or not? Or change it, take root of x square plus 1 minus x and root of x square plus 1 plus x, as you wish. Check it out. Think of it. Is this correct or not? This you can digest. Use this to substitute this. Now, can we find the value of this in terms of t? When we'll add, this will get cancelled, x and minus x. Or if when we'll subtract, let's say, when we'll subtract, this will become 0. This will become what? This plus this. Okay, that means 2 times of this equal to this minus this. That means t minus 1 by t. Or we can say 1 by 2. So if we are subtracting, correct? We can use this to substitute the value of this over here. Any problem in that? Just think about it right now itself. We can solve this and use the value of root of x square plus 1 over here. Here there is a minus, so what will come? T minus 1 by t will come. The value will be, and into 2, so 1 by 2 will be multiplied. Or instead of writing like this, take ulta. It will be easier to derive. Wait, root of x square plus 1, if plus x if we are taking as t, then root of x square plus 1 minus x will be 1 by t. Okay, add them. Simply add them. 2 times of this will be equal to t plus 1 by t, and write a plus over here, and 1 by 2. 2 times of this will be equal to t plus 1 by t. So this will be equal to 1 by 2 into this. Now everything is substituted in terms of t. Any problem? Dt. Now dt will not create any trouble for us. Correct? What will this become? Here we have t to the power n only. So t to the power minus n. No, things are not getting cancelled. No, t square plus 1 by t square. That means this will become, okay, this will just become t square plus 1 by t square. And this t will get cancelled. Not a problem. Okay, 1 by t to the power, this you have to solve. This when you will solve, t square plus 1 by t square, and this t will cancel one of the t in t square. So what are we going to remain with? Will remain with 1 by t to the power n will be there, and from this one we'll have 1 plus 1 by t square, and dt will remain. Okay, we'll multiply t to the power n inside. So we'll have 1 by t to the power n plus integral of 1 by t to the power n plus 2. That we can find. T to the power n, 1 by t to the power n. That means 1 by t to the power n means t to the power minus n. So I'm writing it over here. It will become t to the power minus n plus 1 upon minus n plus 1 plus t to the power n plus 3 minus n plus 3 upon minus n plus 3. Now substitute your value of t over here, which is this, and you'll get your final answer. It will be very complex and long, definitely, something like this. So this is how you'll have to solve this particular problem. If you see something like this, only 1/3 in the denominator to the power n, directly substitute it as t and then proceed in the problem. That's the method. Let's move ahead. Whenever we see big powers inside other power, we take some power of the x common and try to solve. Okay. We'll understand this thing with the help of problems only directly. For example, see what is written over here. Let's check this. If you see algebraic expressions and big powers of x are used there. So try to take the highest power of x common out from the denominator. Mostly from the denominator, you'll be able to take the highest power of x common out. For example, if we see over here, if we take x to the power n, here also x to the power n we can take common. Here also x to the power n is taken out common. So here x square was taken. So that's why this is how it's just saying that take the highest power of x common out in the denominator whenever you see big powers in the expression, right? 8, 6, 7, and it is becoming 14. So highest power over here in the denominator is this, because 7 into 2 will become 14, right? Square is there. So we'll have to take the highest from the denominator only. We have to take the highest power of x common out. And then some things are given. See here, you'll first time, if you're reading integration for the first time, here you'll see that how constant is being used. Okay, how constant is being used. Now first let's try to understand how to solve it. The method, general method, whenever you see big powers in the from the denominator, what you do, you take the highest power of x common out. Over here, what can we do? Here, if we take x to the power 7 from the denominator, highest power is x to the power 7. But when we'll take it common out, what we will get? We'll get x to the power 14 out. Correct? We'll get x to the power 14. Check it out. Try to take it out common. Right? In the denominator, let me write. So this will become 5x to the power 8 plus 7x to the power 6 divided by, from here I'm taking x to the power 7 common in this bracket. Outside what will come? X to the power 14 will come. Na? If I take x to the power 7 common from here, this will become 1 by x to the power 5. This will become 1 by x to the power 7. And this will just become 2. Okay, what will come common out of the entire bracket? X to the power 14 will come out. Sorry. X to the power 14 will come out. What will remain inside? A 2 plus 1 by x to the power 5 plus 1 by uh, 1 by x to the power 7. Now, why did we do this? Because see, mostly if you can see, the derivative of this is written over here. No? Can you see? Can you observe that the derivative is written in the numerator? Can you? Okay, square is also there, right? So square we are writing. What should we substitute now? If you cannot see, just take this x to the power 14 in the numerator. You'll be able to see. So what will this become? 5x to the power 8 by 14. That means 5 upon x to the power 6 will be in the numerator plus 7 upon x to the power 8 will be there in the numerator. Now are you able to see the derivative of this is sitting in the numerator? 2 plus 1 by x to the power 5 plus 1 by x to the power 7 whole square, and this thing is dx. What should you take t as? It's very simple to understand. This, if you'll take t, you'll have this when you differentiate on the both sides. Correct or not? So just take this as t. Try taking 2 plus 1 by x to the power 5 plus 1 by x to the power 7 as t. Differentiated both the signs, both the sides, you'll get minus of 5 by x to the power 6 plus 7 by x to the power 8. Differentiated. Dx is equal to dt. Correct? So this entire numerator we have. Now the problem has become simpler. What we'll write? We'll write this became this into dx is dt. So dt minus will come out common outside, and in the denominator we'll just have t square. We'll differentiate it. Achha, dt is already put there. Okay. So this integral will be nothing but 1 by t, minus minus will get cancelled. So 1 by t plus c directly you can write. Right, minus 2 will also come out, so minus minus will get cancelled, not a problem. Now just substitute the value of t, because for the further question you'll have to substitute the value of t. Now see how this constant is being used over here. Value of t, when you substitute, what is your value of t? So this will just become 1 by t, your integral, I'm writing it as I, became 1 by, okay, f of x is mentioned, no? So instead of this, f of x, your f of x is 1 by 2 plus 1 by x to the power 5 plus 1 by 2 plus 1 by x to the power 5 plus 1 by x to the power 7 plus c. And it is given your f of 0 is equal to 0. That means your c is equal to 0. F of 0 is equal to 0. That means your c is equal to 0. And f of 1 is equal to 1 by k. So put f of 1. What will be f of 1? 1 by 2 plus 1 plus 1. That means 1 by 5. 1 by 5. 2, 3, 4. No. Plus 1 plus 1. 1 by 4, right? 1 by 4 plus c. Right? F of 1 is equal to f of k. Sorry, f of 1 is equal to 1 by k. So this 1 by 4 plus c is equal to 1 by k, and your c is equal to 0, which you already found out using this one. So your k is nothing but equal to 4. K equal to 4 should be your correct answer. This is how you found c using this. When you found c, you used it over here, and then you found that 1 by 4 plus c is equal to 1 by k. 1 by k, that means k is equal to. That's how c is being used over here. Now let's look at this problem. Okay, this we didn't see. Now what should we substitute? Tell me. Think of what should be the substitution. Leave this part. Okay, just try to integrate it. Try to integrate this, and before integrating, try to think what should be substituted. What should be the substitution? Here I think it's easier to, because it looks complicated, the problem looks complicated because trigonometry is being included. But see, if you are able to start, that means if you are able to substitute, how do you know what to substitute? So Darshan, that's what I'm saying. Formats, with practice you'll be able to see. Here I'll tell you, most of the cases, whichever's derivative you are able to see, any term is there whose derivative is also there in the problem with dx, multiplied with dx, derivative multiplied with dx. Substitute that without even thinking. If you are not able to see that, then you'll have to hit and try. Not hit and try, with practice you'll be able to know that generally this is going to be the substitution in this kind of problems. So when we are discussing problems, we are also discussing the type of substitution. For example, over here, cos x dx is sitting there. Cos x dx will be the differential of sin x. Correct? If you take sin x equal to t without even thinking, it's not that only one substitution is going to solve your problem. There can be different substitutions also which can solve your problem. But smartly you'll have to think. For example, in these type of cases, when cos x dx is there, suppose. So if you're not knowing anything, simply take sin x equal to t, because sin x, when you differentiate sin x, you'll get cos x. Correct? So you know that cos x dx is going to be equal to dt. That we know. Cos x dx we know is going to be equal to dt. Now sin x you have taken as t. Now can you write everything in terms of t? Can you write everything in terms of t? For example, over here I can write this entire problem. Cos x dx became dt. What did the denominator become? T cube into 1 plus t to the power 6 to the whole power 2 by 3. What's the problem? Everything is in terms of t. Now try to solve it. Now what was the second thing which we learned? Take, whenever you see powers in the denominator, take the highest power common out. So if from here, if you take t to the power 6 common, what will happen? If you'll take t to the power 6 common from this bracket, t to the power 6 will come common out, t to the power 3, and okay, wait. When you'll take t to the power 6 common, what will come out common? T to the power 6 to the whole power 2 by 3. T to the power 6 to the whole power 2 by 3. That means t to the power 4. Correct? When you'll take t to the power 6 common from this bracket, t to the power 6 to the whole power 2 by 3 will come out. So that means what will you remain with? T to the power 3 into t to the power 4. Here what will come? 1 by t to the power 6 plus 1 to the power 2 by 3. Correct? So this problem will become integration of dt by t to the power 7 into 1 by t to the power 6 plus 1 to the whole power 2 by. Now again you'll have to do the substitution. Definitely. Once more you'll have to do the substitution. Problem is not over yet. This is also not in the general format. But 1 by t to the power 6 plus 1. If you'll differentiate it, what will you get? You'll get t to the power 7. 1 by t to the power 6, that means t to the power minus 6. T to the power minus 6 differentiated, t to the power minus 6 minus 6 into t to the power minus. That will be the difference. So that you have t to the power 7 you have. So put this as t, or not t this time. You have to put this as u. 1 by t to the power 6 plus 1. This will be your u. Correct? So you'll have minus 6, sorry, minus 7, na? Minus 6 will come or minus 7 will come? Okay, minus 6 only will come. Minus 6 will come in front, divided by t to the power minus 7. So t to the power 7 will come over here, equal to d. Okay. dt is equal to du. When you'll differentiate both the sides, this into dt will become your du. Okay, so this thing you have already, and minus 6 is not going to create trouble for you because you can divide that. Okay, so what did your dt become? By du by this, sorry, dt by this became your du. dt by this multiplied with 1 by 6 became your du. Directly you can substitute now. Try to solve further. Okay, I'll solve. There is very less space remained. This thing, can you observe? This thing is your du now. This thing is created over here when you differentiated both the sides. Okay, so what did your problem become now? T, this became du, uh, du, and here minus 1 by 6. Okay, minus 1 by 6 will think about it. 1 by t, this we took as u only. Du by u. Du by u to the power 2 by 3. Du by u to the power 2 by 3. Okay, and minus 1 by 6 you can multiply outside. Minus 1 by 6 into du divided by u to the power 2 by 3. What will be the differential? U to the power 1 by 3 upon 1 by 3. U to the power 1 by 3 upon 1 by 3, and minus also will become plus, or let it remain. Okay, plus c. Plus c definitely. Now you'll have to substitute things back again. Okay, you'll have to substitute all these things back again. You'll have to substitute as this in this. This is your final integration. Now you can substitute the values. Minus 1 by 6 u to the power 1 by 3 upon 1 by 3. So 1 by 2 only will remain, minus 1 by 2 u to the power 1 by 3 plus c. What was your u? 1 by t to the power 6 plus 1. Okay, what was your t? T was sine x. So entire thing 1 by sine x to the power 6 plus 1, that will become minus 1 sine to the power 6x plus 1 upon sine to the power 6x. Okay, let me write. Become minus 1 by 2. See, your u is 1 by t to the power 6, and t itself is sine x. So directly you can write, no, 1 by sine x, 1 by sine to the power 6x plus 1. That will become sine to the power 6x plus 1 upon sine to the power 6x to the whole power of 1 by 3 plus c. Now can you relate? Okay, now can you relate? This can be written as minus 1 by 2 cosec to the power 6x multiplied with 1 plus sine to the power 6x to the power 1 by 3. This is written on the right side. Correct? This is written on your right side. So what is f of x? F of x is minus 1 by 2 cosec to the power 6x. What is your lambda according to the comparison? Lambda is nothing but 3. So lambda into f of pi by 3. That means lambda into f of pi by 3 will be nothing but, lambda is 3. 1 by lambda is written over here. So 3 into f of pi by 3. 3 into minus 1 by 2 into cosec to the power 6 pi by 3. This will come out to be minus 2. 6 will come here, and then finally your answer will be minus 2. Right? Instead of x, you just put pi by 3 over here. Final answer will be minus 2. Do we have that in the options? Yes. So substitution is going to play the major role in entire integration. Do not take it lightly. Practice it as much as you can without any trouble. Okay, let's move ahead. One more format or one more type. What do you think should be our substitution over here? Whenever you see, learn, you can note this out down also. Whenever you see linear term inside square root, right? Linear term inside square root which is in the denominator, put that equal to t without even thinking. 1 plus 2x, if you put equal to t, or this entire thing, square root thing as t, this will become 1 plus 2x is equal to t square. Okay, directly put this as t square. Now differentiated both the sides. So your t square, 2 dx will be equal to 2t dt. Okay, 2t dt you'll get 2 dx is equal to 2t dt. Now what do? You try to write everything in terms of t. You want to write everything in terms of t. So what will this become? Integral of denominator, there is no issue. Denominator is t only. What will numerator become? X square. What is x from here? X is t square minus 1 by 2. What is x? What is the value of x? Just when see standard type of problem. Learn this as it is. Avnit, which thing? This thing. Okay, I'll explain again. Whenever you see square root in the denominator, not always. Whenever you see linear term inside square root in the denominator, put that entire term equal to t or that equal to t square. Same thing. Now differentiated both the sides. 0 plus 2 dx equal to this side, if you differentiate, 2t dt. Okay, both sides we are differentiating with x only. So 2t dt. This is 2 dx and this is 2t dt. 2 and 2 also you can cancel. So dx is equal to t dt. Dx became t dt. Now see, denominator there is no problem. This is t. You want to write x square in terms of t. How will you write x square in terms of t? X square will be t square minus 1. What is x? T square minus 1 by 2. T square minus 1 by 2 whole square. That way you can write t square minus 1 divided by 2 whole square. What is your dx? Dx is t dt. So here into t dt. Now this t got cancelled. Any problem? This t cancels the other t. Now we can write. So what do we have now? T square minus 1 by 2. This by 2 also. This by 2 square. So 1 by 4 will come out. T square minus 1 whole square will remain with dt. Okay, what will this become? 1 by 4 into t to the power 4 plus t plus minus t square plus 1 dt. You know the integral? 1 by 4 into t to the power 5 by 5 minus t to t cube by 3 plus, that will be your answer. Just substitute your t again. So it will become 1 by 4 into root of 1 plus 2x. You can substitute, right? There is lack of space. So just instead of t, write everywhere root of 1 plus 2x. That will be your answer with plus. Okay. I'll show you the answer. Yeah, this was our answer. After substitution, it will look this long. Same thing. You are seeing a third cube root square root of linear term in the denominator. Same strategy every time you can follow. Just put this equal to t. So x plus 3 to the power 1 by 3 equal to t. That can also mean x plus 3 equal to t cube. Right? Differentiated both the sides. This will become 1 plus 3 dx equal to 3t square dt. How did this help? Hey, left side we are making a mistake. 3 plus x plus 3, no? So only dx. Only dx. 3 will become 0. Dx will be equal to 3t square dt. Right? So what will your integral become? Integral will become, now x plus 3, this we have, denominator we have already taken as t, not a problem, directly you can substitute. Look at the numerator, 2x square. How will we get 2x square from? Think, how will we get 2x square from? Here. What is your x? X is nothing but, x plus 3, x is nothing but t cube minus 3. So x square, that means 2 into t cube minus 3 whole square. That's it. And your dx is nothing but into 3 t square dt. 1 t again will get cancelled over here. So 6 will come out. 6 will come out. 3 into 2, 6 will come out. T multiplied with this, t to the power 6, that will become t to the power 7 minus 9t minus 6t to the power 4. I think this is correct. T to the power 6, 3t, yeah. Just check once. And this entire thing with dt. You can integrate this very easily. This will become 6 into t to the power 8 by 8 minus 9 into t square by 2 minus 6 into t to the power 5 by 5. Let's check. Yes, we are getting this thing only. Right? Now substitute the value of t and this will be your final answer. So what did we learn? If we see a surd, linear surd in the denominator, cube or square root or cube root generally, put that entire term equal to t, that will help your problem. Right? Remember these general strategies which are going to help you further also. Look at this question which looks horrible. Try to connect, try to find the first step. Try to find the substitution in this. That will be all. If we can find the substitution, that is enough. If we are at this point of time, if we are even able to find the substitution, that is very good for us. Okay, there is nothing bad in that. Look for substitution. You can comment also if you are listening right now. Try to look for, problem looks complex because a lot of things are there, but anything which is common everywhere. You're asking, no, some students are asking, sir, how to know what to substitute? Look for the common thing, look for its derivative. Look for derivative of a term in the same problem. Okay, for example, over here, what is the most common thing? 2x minus 1 is the most common thing. You can see 2x minus 1 here, here, and here also. Can you see 2x minus 1 everywhere? Right? So what can I do? I can take 2x minus itself as t. My first strategy would be taking 2x minus itself as t. Before that, look at the denominator. Look at the denominator. Can you create 2x minus 1 over here? Right? In the denominator, if you write like this, 2x minus 1, I'll write the entire thing, cos of square root of 2x minus 1 whole square plus 5. In the denominator, what is this? What is this thing? 2x minus 1 whole square plus 5 only. Isn't this 2x minus 1 whole square plus 5? What is 2x minus 1 whole square? If you take common also, then also you'll understand. 2x minus 1 whole square will be 4x square, right? Plus 4x minus 4x plus 1. Plus 1, sorry, minus 1 plus 6. So plus 5. What you can do? 2x minus 1 whole square plus 5 is sitting over here also. So if you want, you can take the entire 2x minus 1 whole square plus 5 as some substitution, or just take 2x minus 1 as some substitution t. So let's take 2x minus 1 is equal to t. Okay, so what will you have? You'll have 2. You'll have 2 dx. Which color did I make? Yeah, 2 dx. Your 2 dx will be equal to dt. right? Dx will be equal to dt by 2. So here 1 by 2 you'll take out common. What will your integral become? T into cos of square root of t square plus 5 divided by t square plus 5. Now I don't need to tell you what are you supposed to substitute. By now, Ore Baba, Manjil is back. No, no, no. Oh my god. Great. T. T square plus 5 itself you'll have to substitute. So where will I substitute? Substitute t square plus 5 equal to some u. So your 2t dt will be equal to du. Correct? Now what will your problem become? This entire thing 1 by 2 2t dt. Acha 1 by 4 it will become, no, now. Uh, uh, uh. Use or one more thing, wait, one more substitution we can do. We can do one more substitution. What if we take this entire square root as some substitution? We can do that also, right? Because we have square root over here. Can you see? We have square root over here. Can't we take t square plus 5 as u square? That will be better. Do you agree with me? See, square root over here, so we'll take t square plus 5 itself as some u square. That will even be better. 2t, because 2 will get cancelled. So it will become 2t dt is equal to 2u du. Okay, 2 got cancelled, t dt is equal to u du. Right? So this, instead of writing cos square root t, we'll have cos t, cos u. We'll directly have cos u. That will be better. That will even be better. Getting my point? So what will this become? 1 by 2 will remain as it is. Achha, 1 by 2, yeah, 1 by 2 will still remain. T t dt, here there was tt, wait, let me write it more clearly. There was dt over here. So this will become 1 by 2 into t dt will become u du, and this will become cos u cos u du, divided by, what will this become? This is your u square. So here u square will come. This will cancel one of them. Now the problem will become easier. Oh, sorry, just a minute. What happened? How will you? Huh? You got cancelled. What did we have here? Square plus 5. That's okay. Okay, this was square root t square plus 5. Then it will be u. Wait. This will be u over here. U itself will get cancelled. Finally, what are we going to have? Cos u du. So cos u du, we know it will become 1 by 2 into sine of u plus c. Sine of u, that means sine of, what was u? U we have taken as square root of t square plus 5. So I think, wait, which one will be your answer? This question is good. You have to repeat it once again. So substitute your u and you will find one of the answer. Let's see. Are we getting the correct thing? What have they done? 1 by 2 sine t plus c we are getting. No, sine u plus c we are getting. 1 by 2 sine u plus c we are getting. and value of u they have taken. Uh, Acha, u is 2x, yeah, this thing. U was t square plus 5, square root of t square plus 5, correct? Square root of t square plus 5, that is why 2x minus 1 whole square plus 5 plus c. Our t was 2x minus 1. T we took as 2x minus 1. So 2x minus 1 whole square plus 5, option A will become your answer. Substitutions. Right, please complete this once on your own. Till here, you must have understood cos u du will be our final integral, and that will become sin u plus c. Sin u ka value will be this one, u ka value will be square root of t square plus 5. So square root of 2x minus 1 whole square plus 5 plus c. Option A became your answer. Directly also you can see. This problem from last year, specifically just substitution. Nothing major, only substitution. What should we substitute? Here actually thinking of what to substitute only is playing the major role. We have, see, tan in this is a big term. I hope you're able to see. I'll write it once again. X to the power 8 minus x square is in the numerator, divided by x to the power 12 plus 3x to the power 6 plus 1. This term, and then tan inverse of x cube plus 1 by x cube. This is there. Whole and so on. This entire thing is there. Now, just try to think over here, which derivative of what is going to give you other terms in the entire integral. This with dx, or let me write dx over here only, dx. Okay. If you can think of, see, you have to quickly think of the derivative of the terms. Just try to think the derivative of tan inverse of x cube plus 1 by x cube. 1 by 1 plus x cube plus 1 by x cube, and then differential of this. So if you take, let's say, if you take your tan inverse of x cube plus 1 by x cube as t, as soon as you think of this, and try to calculate its derivative in your mind, you'll be able to see most of the problem was solved. Why? Because see, what will be the derivative? 1 by 1 plus this entire thing, that means x cube plus 1 by x cube square, 1 square plus 1 plus square of this, multiplied with derivative of this, that means 3x square plus 1 by x to the power 4. Oh, sorry, 3 by. 3 is also there, no? Yeah, 3 is there. 3 is there. Here 3 will come. And if here 3 is coming, 1 minus also will come. Wait, let me. This will become minus of 3 by x to the power 4. Correct? Derivative, just chain rule we have applied. First tan inverse x derivative, then multiplied with derivative of this thing. Now solve this. What are we getting? Solve this. X to the power 4, here x to the power 6 is going to be created. Solve this and check what are we getting. Aren't we getting what we have in the question? What will this become? 3x to the power 6 minus 3 upon x to the power 4. This will become 3x. Wait, I'll need some more space. This will become 3x to the power 6 minus 3 upon x to the power 4. Okay. What will this become? Take the numerator above. X to the power 3 to the power, so x to the power 6 will be in the numerator. What will be your denominator? What will be your denominator? X to the power 12 plus 3x to the power 6 plus 5. Oh, sorry, plus 1. X to the power 12 plus 3x to the power 6 plus 1. Look now, compare this thing and this thing. What did we need? We needed this only. This is the numerator, this is the denominator now, right? Okay, we have differentiated, so this dx is equal to dt. This entire thing dx is equal to dt. Solve this more. Even now you can solve. X to the power 4, x to the power 6. This will get cancelled. This will become x to the power 2. X to the power 2 into x to the power 6 will become x to the power 8 minus x to the power 2. And 3 will come out common. Right? When you'll solve this, more space. See, x to the power 4 will cancel this 2 times. Then x square into x to the power 6 will give us x to the power 8 minus x square. 3 will come out common. So 3 into this entire thing dx is equal to dt. Correct? 3 into this entire thing dx is equal to dt. So what will our final integral will become? Here I am writing finally. Wait, I'll write once again. This will become 3 into x to the power 8 minus x square divided by dx over here divided by this thing x to the power 12 plus 3x to the power 6 plus 1 into, okay, nothing else. That's it. Right? This thing is your dt. This thing is your dt. So what did the final integral become? This became nothing but 1 by 3 into integral of dt by t. Correct? Right? That simple. If you understand the substitution, if you know the substitution, it's not going to be a problem for you. This is very simple. 1 by 3 into ln of t plus c. This will become 1 by 3 into ln of t plus c. What is your t? T you can put again. Ln of tan inverse of x cube. Ln of tan inverse of x cube plus 1 by x cube plus c. All options are same. Kya? Hey, no, not all the options are same. Not all the options are same. Only one option is correct, which is this one. There is no power on ln. There is no power on ln. Ln of t, t is just this, tan inverse of x cube plus 1 by x cube plus c. So option B will be your answer. No, 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 wait. 1 by 3 they have discluded, right? So 1 by 3 is going up. Option A will become your answer. 1 by 3. This 1 by 3 will go above, and above the ln. 1 by 3 will go above as right. So option A will become your answer. Right, 1 by 3 they have put on the log. So 1 by 3 will become the power there. Okay. Now again, some more standard substitutions, some more things to remember, some more things to memorize and mug up. Okay, let's see. Okay, this is here actually this we don't use generally. Without this also it will work, but yeah, just remember, if you see somewhere a square minus x square or a square plus x square or inside square root a square minus x square or a square plus x square, it's going to help you if you take x as a sine theta or a cos theta, right? You can see also substitution will actually help you. It will become a into 1 minus sine square theta or 1 minus cos square theta. That will help you only, but these I don't think you'll need to remember, but still you'll have a note of these. These are substitution that if you get substitute, direct substitution, if you're getting these kind of terms, then just like in parametric form we do, right? Take your x as a sine theta or a cos theta. That is going to help you. Moreover, here what's important is these substitutions. Now some more substitutions, direct substitutions are going to be needed, which are going to be helpful for you. You can do it by substitution method, which we have learned in the normal first list that we saw, but you won't have that much of time, so it's better that you directly remember them, right? You can remember them also. Here also you can relate, right? 1 by square root of a square minus x square, integral of this will be sine inverse of x by a, minus 1 by square root of a square minus x square, integral will be cos inverse of x by a. Here if you have if square root is not there, a square plus x square is there, then tan inverse of x by a. If root is not there and minus 1 by a square plus x square is there, then it is 1 by cot inverse of x by a. Here also 1 by a. Sometimes students forget this 1 by a thing. Okay, we have to remember 1 by a. This is for sec inverse of x by a. 1 by a into sec inverse of x by a. This is for 1 by into cosec inverse of x by a. So 6 of these and some more, right? Some more. Only this. Suppose if you only have this, dx by square root of, sorry, integral of dx by a square minus x square. Right? A square minus x square. You don't have a square minus x square right now. Right? So a square minus x square, if you have, then it will be 1 by 2a into ln of a plus x upon a minus x. You can see, everybody remembers these with their own tricks, just like you remember periodic table with your tricks. So once you write them down and try to mug them up, right, you'll be able to remember them. You'll be able to actually memorize them. Don't worry about it. 2-3 times you'll have to write. That will be done, and your mind will automatically make a pattern to remember these or to memorize these. Dx by x square minus a square 1 by 2a ln of x minus a upon x plus a. If you have square root of x square plus a square, here we did not have square root of x square plus a square, only minus. Without square root we had plus. So square root of x square plus a square ln of x plus square root of x square plus a square, root square root of x square plus a square plus c. And here minus is there, so minus will come. Okay. This you can use a technique that if you the minus term will come first, here positive term will come first. Your own pattern. I won't tell you a pattern. Everybody remembers with their own pattern. With practice anyway, you are going to memorize them without any trouble. Don't worry about it. Okay, a few more. So yeah, there is a long list of the standard integrals which you have to remember. There is no other book. Directly in, not in the denominator, directly if you have square root of a square minus x square, this is very, very important. Many times you'll get to use these two. Okay, these two definitely many times you'll get to use. Even this one also, it's, there is no harm in memorizing all of these. Okay. Okay, let's see how useful they will be, and without them question can become very long. Here if you go on substituting and solving, question can become long. If you directly remember this formula, then how simple it is. See, you know the integral of 1 by x square plus a square, right? This is, instead of x we have 3x minus 2. Here instead of just a minute, here instead of x we have 3x minus 2. So if it was x, the integral will be ln of mod of x plus square root of x square plus a square. So instead of x we'll write 3x minus 2 plus square root of 3x minus 2 whole square plus 1 square. That's it. And what will we divide with? We'll divide this entire thing with 1 by 3 because coefficient of x. The first method, f of ax plus b, right? Coefficient of x. Instead of x, we have 3x minus 2. So directly we'll be able to write. This one also, same thing. Same thing we have, right? If we remember this formula, we can easily write 1 by, what is the coefficient? Coefficient of x, don't put 2, minus 1. That means 1 by minus 1. So minus of ln of 2 minus x plus square root of 2 minus x whole square plus c. Okay, directly you will be able to write, and many times they'll be in the options. So it will save your time. More you remember, faster you will be in integration. Now over here in this question, very important concept will, not concept, very important substitution will be learning. First, try to think of this question on your own. I'll give you a minute. See, in starting also, in the starting problem also, we came across somewhat this type of a problem only, if you remember. Very starting. I told you that if you see sine 2x, then make a use of cos x plus sine x or cos x minus sine x. If somebody is watching from the starting, or you can relate, try to think. What do we have? We have, I'll write from here, cos of x minus sin x upon square root of 8 minus sin 2x dx. Okay, this is given equal to something that will check later, but first integration. If we cannot integrate, then we cannot solve only further ahead. Okay, this is what we have. What should we substitute? If we substitute sin x, if we substitute its differential is not there, or some term with dx, do we have something like that? Okay, this same type of problem has been repeated in mains, so I'll tell you what to do over here. Here the best thing to do is take sin x plus cos x as t. Why I'm saying? Because sin x plus cos x when whole squared always gives you 1 plus sin 2x. Sin square x plus cos square 1 plus 2 sin x cos x sin 2x. Isn't it? And this is going to be actually helpful over here. When you'll take your sin x plus cos x equal to t. Why am I saying? You can also relate. Why? Because its differential is sitting over here. Right? When we saw sin x differential cos x in the numerator, we took sin x as t. Here we are seeing the differential of sin x plus cos x. So we'll take sin x plus cos x as t. What's the problem? So this will become cos x minus sin x dx equal to dt. And this is what we have in the numerator. Correct? And square of this is also giving us 1 plus sin 2x. Why? Because like, look, here we can create 1 plus sin 2x or 1 minus sin 2x. Okay. Now this is our t. So my t square is equal to 1 plus sin 2x. That's what I'm writing over here. Now what did the numerator become? Numerator this into dx is your dt. So numerator is just dt. What did the denominator become? Square root of 8 minus sin 2x. That means 8 minus t square minus 1. 8 minus t square minus 1. That means 9 minus t square. 8 minus t square minus 1. That means 9 minus t square. And the problem is solved here itself. Correct? This is our standard integral. This we know. This is our standard integral dt by square root of 3 square minus t square. A square minus x square. 1 by square root of a square minus x square. We know. Sine square x by a. Right? So this will become nothing but sine inverse x, sorry, t by, what is a here? 3 is a square minus t square. So 3 is your a, sine square, sine inverse t by 3 plus c. What was our t? T was this, sine inverse of sine x plus cos x. Sine, yeah, here it is given, no? This integral of this is given equal to this. So sine inverse of sin x plus cos x by 3 plus c. So what did a become? A become 1. There is no coefficient over here. What did b become? B become 3. So option B is our answer. A became 1, B became 3. Okay. Substitution is going to come with practice. Okay. With practice only it will come. But yeah, standard substitution, if you're listening to this carefully, if you're solving on your own here also, you'll see that these type of substitutions are used in multiple problems, multiple of them, many of them. Okay, now we have begun with some algebraic formats. Sorry, algebraic formats. This is also very sorry, just a minute. You read this out. I'll take a 5 minutes break, please. I'll just quickly drink water and come. Forgot to bring my water. You can also take a break if you want. Okay, algebraic formats. Now, algebraic formats are, it's better. See, in every book also, same type of things will be mentioned. As it is, you should remember, because you won't have time to, think or try things and then reach to a non-conclusion. Do not reach to a conclusion or do not reach to a solution. If you remember the formats as it is, I can bet you, I can assure you that nobody can stop you in integration. Very important thing. Formats, it's an entire integration chapter. If you ask anybody, it's all about formats. Two things: substitution, formats. Substitution in formats, nothing else. Algebraic formats, then trigonometric formats also we'll study. But first, algebraic formats. I think total of 4 to 5 formats are there. Remember them as it is. You start your integration, start the solving using the format, specific format. This is going to actually play a major role over here. Okay, let's see one by one. First format, if you see a linear by quadratic or linear by square root quadratic. Here p of x, here this p of x, this polynomial is either linear or constant. Constant by quadratic, till now we haven't seen. Till now we haven't seen anything like this. If you're thinking, sir, we have seen something like this. No, we were having square root linear, right? In the problems that we solved, we directly substitute it as t. Okay, don't confuse yourself there that, sir, we know how to solve this, we'll substitute. No. Okay, here there is a specific standard method that only if you follow, you'll reach to answer within time. Otherwise, you'll get lost somewhere. Remember that thing. If you have constant by quadratic or linear by quadratic, or if you have constant by square root of quadratic or linear by square root of quadratic, this is what you are going to, same thing you'll do. What will you do? We'll understand this by problems. So basically, I'll give you an idea. If you are getting constant by quadratic, that is easy. Constant by square root quadratic is also easy. What will you do? You will create, see, now your standard formats are going to be used, which we just saw, the list which we just saw. What will you do? You'll try to complete a square, try to write it as square, perfect square, and then some constant. So either 1 by a square minus x square or 1 by a square plus x square will be created, or 1 by, right, in the case of constant by quadratic, or 1 by square root of a square minus x square, or 1 by square root of a square plus x square will be created, and that will give you the answer directly. If you have linear by quadratic, then there is a method, I'll tell you, right? In that case, what you need to do, here it is written in language, but I'll tell you with, it's written that in linear, then create derivative of the quadratic in the numerator. Okay, how to do that? We'll learn step by step, problem by problem. First thing is constant by quadratic. Very easy thing, not a problem at all. What you need to do, you need to complete a square over here. If you are able to complete square over here, you'll be able to write it in the form of 1 by a square plus x square. That integration, we know that are the standard integrals that we know. So try to complete the square over here. If many of you are, I'm sure that by now you know how to complete square. If not, then there is no problem. Take 2 common, right? X square minus x plus 3 by 2 you'll have. Now, add and subtract the square of the coefficient of x. What is the coefficient of x over here? Sorry, add and subtract square of the half of the coefficient of x. What is the coefficient of x? 1. What is the half of coefficient? 1 by 2. Square 1 by 4. So add and subtract 1 by 4 over here. So 2 into x square minus x plus 3 by 2. First plus 1 by 4 you write over here, plus 3 by 2 minus 1 by 4 you write like this. That will be better. Okay. Now 2 into, what will this become? X minus 1 by 2 whole square we are getting, right? We are getting x minus 1 by 2 whole square. This entire thing is giving you x minus 1 by 2 whole square. Correct? And what is this becoming? 3 by 2 minus 1 by 4. 3 minus 2. Yeah, 6 minus 1, 5 by 4 plus 5 by 4. You get it. So what did this problem become? Over here, we are just going to do 1 by 2, right? Integration of dx divided by 1 by 2 will come out. This 1 by 2, from this entire thing, 2 is common. This denominator is this. So 1 by 2 I have taken out. This will become x minus 1 by 2 whole square plus root 5 by 2 whole square. This is our standard format. Tan inverse of this is a square plus x square, right? So 1 by a into tan inverse of x by a. That means 1 by 2 into 1 by a, that means 1 by root 5 by 2. So 2 by root 5 into tan inverse of x by a. Oh, what is your x over here? X minus 1 by 2. So x minus 1 by 2. Coefficient of x also will have to divide, but here coefficient of x is 1, so there is no problem, right? Otherwise we'll have to divide by coefficient of x also, because it's not x, it's ax plus b, right? Divided by root 5 by 2, tan inverse of x by a. This entire thing plus c obviously will be there. This is going to be your final answer. And how completing the square is helping, you must have realized. Why are we completing the square if we have quadratic in the denominator? We are trying to create x square plus a square in the denominator, so that we can directly write its integral. Again, the list is important. Memorize it. Direct answers you'll get. Otherwise, you'll get stuck. You won't be able to proceed further. Yeah, this only, right? 1 by root 5 finally. Yeah, this 2 will get cancelled. So 1 by root 5. X minus 2x minus 1. 2x minus 1. This 2 and 2 also will get cancelled. 2x minus 1 by root 5. So it will become 1 by root 5 tan inverse of 2x minus 1 by root 5 plus c. This is written over there. Okay. Now, linear by quadratic. As I told in the starting, everything is going to be connected. So, the other formats will use these formats also. So, practice them wisely and carefully. Whenever you have linear by quadratic, now what do we want actually? If you want to substitute something, if you want to do, you know that if the derivative of this was here, then you could directly substitute this as t and you could solve the problem. If the derivative of your quadratic was in the numerator multiplied with dx, then you could substitute this as t and then you can proceed ahead with your problem. So this should be in the form of, so what do you basically need? You want that your 3x plus 2 should be equal to, instead of 3x plus 2, what do you want? You want lambda, one constant, into derivative of this, that means 2x plus 4 plus some other constant, let's say mu. Okay, if this was the scene, then you could proceed ahead. So this is the format also, the method which was written in the starting, that try to write your linear in terms of derivative of the quadratic. So in terms of derivative of the quadratic, you'll try to write your linear like this: 3x plus 2, which is the linear, 3x minus 2, 3x minus 2. 3x minus 2, you'll try to write it in this form: lambda into derivative of this plus mu. Correct? Now over here you'll find your x, sorry, your lambda and mu. By comparison, you'll be able to find your lambda and mu, and then you'll be able to write the same thing, 3x minus 2 in these terms. So what is the coefficient of x over here? Coefficient of x on the left side is 3. What is the coefficient of x on the right side? Lambda into 2, that means 2 lambda. So this gives you lambda equal to 3 by 2. What is the constant over here? Minus 2. What is the constant over here? 4 lambda plus mu. 4 lambda plus mu. That means 4 lambda means 4 into, sorry, 2 into 3, 6 plus mu. That means minus 2 is equal to 6 plus mu. That means your mu is equal to minus 2 minus 6 minus 8. This is your mu, this is your lambda. So your 3x minus 2, this can be written as lambda into 2x plus 4. That means 3 by 2 into 2x plus 4 minus 8. And this is same now, right? You can solve and see. But you have written it in a different form where 2x plus 4 is the derivative of your denominator. Okay? Divided by this quadratic only, x square plus 4x plus 3. Now, how did it help? It helped. See, this will become your, um, now you can separate the terms. 3 by 2, first, for first integral, you'll write, wait, 3 by 2 you'll take out. Integral will become 2x plus 4 divided by x square plus 4x plus 3 minus 8 you'll take out. Integral of 1 by x square plus 4x plus 3. First, this you know how to solve by completing the square. This one also you know how to solve. You'll take x square plus 4x plus 3 as t, although you can solve now. X square plus 4x plus 3 equal to some t. So your 2x plus 4 dx will become equal to dt, right? So this entire thing will become dt by t. That means ln of t. So the problem will be solved. This will be 3 by 2 into ln of t, where t is this, ln of x square plus 4x plus 3. And this you know how to solve. Minus 8 times of complete the square, and you'll be able to solve this. This is x plus 2 whole square is being created over here. X plus 2 whole square plus 3 plus 2, 5. No, x plus 2 whole square minus 1 square. Yeah. So this will become x plus 8 into integral of 1 by x plus 2 whole square minus 1 square. Right? A square minus b, a square minus x square minus a square. So this will be 8 times ln of x plus 1 upon x minus 1. Ln of x plus 1 upon x minus 1 plus c. This will be, this is ln. Check once. Oh, wait. This we have solved wrongly. Wait, just a minute. X plus 1, how can we directly write? It will be x plus 2 minus 1. So yes, x plus 1 only. And denominator x plus 2 plus 1. So x plus 1 upon x plus 3 it will be. X plus 1 upon x plus 3. Check the formula, okay? Check the formula. If you are not able to recollect, please check the formula or the list which you have made and then solve. Okay. This plus c. 8 times, yeah. And 1 by 2 also will be multiplied. So this by 2, you can create 4 over here. 4 times of x plus 1 upon x plus 3. Try to attempt this. Okay, Ahan. Solve and send the answers. It's okay if you're finding it's easy, no problem. Good that you're finding it's easy. Okay. But there are many students who are struggling with this. So let them study. Don't mind. Over here. Come on. Try to think. Already we know the strategy because cos theta d theta is there. So we are going to take sin theta as t. Okay. We are going to take sin theta as t. Correct? Cos theta d theta is there. Without even thinking, we can take sin theta as t. Your cos theta d theta will become dt. Okay. Is the problem solved now? Most of it is solved. Just one format. So see, in every question, all the juice, all the summary of your integration is going to be used. This is only the difference between NCRT or JEE Mains or JEE Advanced, right? If you look at NCRT, you'll see that everything is in format. Like you'll know that this question is going to be solved by this format only. The other concepts are not going to be used. But if you'll go at JEE Mains level, things are connected. In Advanced, they are even more connected, right? Other chapters are also connected. So that's how it's going to propagate. Remember that. In Mains, you'll have to connect all the concepts that you have learned. In board level, you'll be able to see, okay, this is direct formula applied or this is direct concept being applied. Here I have to use the standard integrals. Here I have to use the substituted integrals. Here I have to use by parts. Here I have to use trigonometric formats. Everything will be connected. Mains, you'll have to connect the dots on yourself. Advanced, even more, right? Even more. That's it. So, okay, what did this become? Cos theta d theta became dt. This will become 5 plus 7t minus 2 cos square theta. So minus 2 times of 1 minus t square, right? Minus 2 times of 1 minus t square. That's it. And right, this question is actually of algebraic formats, but they have used a little bit of trigonometry over here. Hey, why am I putting d theta? Okay. So what did it become? I is equal to integral of 2 into, it will become 2t square plus 2t square plus 70 plus 3. Okay. 2t square plus 70 plus 2, oh no, 5 minus 2, yeah, plus 3 dt. This you know. Complete the square and you can solve it. Even if you don't want to complete the square and you want to, you're thinking that sir, only completing the square is the way, even you can factorize and proceed. In constant by quadratic, you can factorize this. If you are able to factorize this and then proceed. Your wish. Okay. complete the square over here and find the answer. We have to move a little bit faster, that's why I'm doing this. Either you can complete the square or factorize and move ahead. This method, this approach, you know, constant by quadratic. Constant by quadratic, here you'll have to just complete the square, write it in a square minus b square or a square plus b square form. Okay, let's move ahead. This is an important format. Because this is important because sometimes we think that over here this is of the form 1 by 1 minus x square. This is not actually of the form 1 by 1 minus x square. Don't apply the formula of 1 by 1 minus x square or square root of 1 by 1 minus 1 upon square root of 1 minus x square, because that's going to cause a problem. We cannot generalize. This is not x, this is e to the power x. If we have x, then only we can apply that, or some linear term in x, then only we can apply the formulas. Here we cannot apply. If you're thinking this is of the form 1 by square root of 1 square minus x square, then no, you're wrong. Okay, this cannot be sine inverse x plus c or sine inverse e to the power x plus c. No, you'll have to think of something else over here. Substitution is going to help over here. 1 by square root of quadratic, this is also not quadratic. I don't know how this problem came at this slide. It should have come earlier, but this is not even 1 by quadratic form. Okay, maybe this is why this problem is here, that you cannot confuse it with anything else. Do not generalize things. Do not generalize the things in integration. You cannot call e to the power 2x as quadratic in x. No. Substitution. If nothing's working, then substitution is going to work. Okay, what to substitute now? Think of it. Here I'll write, if you are not able to see it clearly, integration of dx by square root of 1 minus e to the power 2x. If you take e to the power 2x common from here, what will happen? The power 2x, if you take common, let's take from the denominator, if you take e to the power 2x common, e to the power 2x out of the square root, it will become e to the power e to the power x. Inside square root, what will you have? 1 by e to the power 2x, that means e to the power minus 2x minus 1. Now this e to the power 2x, e to the power x, you can send in the numerator also. So it will become e to the power minus x upon square root of e to the power minus 2x minus 1 dx. Now you know what to do. Now you know e to the power minus x, if you put as t, then e to the power minus dx will become dt. Correct? Now you can create into a algebraic format. How? Substitution only. If you take your e to the power minus x as your t, then differential of this is also e to the power minus x dx is equal to your dt. Correct? Here one minus will also come. Why did we do this? Because see, e to the power minus you'll take common, no problem. E to the power minus x dx is your dt. So this will become dt divided by 1 minus or t square minus 1. This will become square root of t square minus 1. This format you know, right? This format you know. Minus of 1 by x square minus a square, you know. Square root of 1 by square root of x square minus a square, you know, ln of x plus this same thing plus c. Correct? So, wait, but still something is wrong over here. T, just a minute. D Okay, first let's write ln of t plus, what have we taken t as? E to the power minus x. So ln of t plus t square root of t square minus 1. All right. Mm, plus c will come. Minus is also there. Now t's value, even if we are putting, it's not helping. 1 by, options are not matching, right? Something wrong we have done. Okay, let me check. Okay, let's put first ln of t's value e to the power minus x or 1 by e to the power x. Let's put like this, 1 by e to the power x plus square root of 1 by e to the power x minus 1. Hmm. Okay, this thing is coming 1 minus e to the power t square, right? So e to the power 2x, okay, minus ln of, if we take the LCM also 1 by, okay wait, 1 by e to the power x plus square root of 1 minus e to the power 2x by e to the power 2x. This 1 by e to the power x will come out common, okay. Ooh, ho, 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 ho. What is wrong? Why are the options not matching? This one, just a minute. Okay, this e to the power 2x, instead of writing square root, let's write, okay, wait, e to the power x. Yes. All right, they have written it like this, minus ln of 1 plus square root of 1 minus e to the power 2x upon e to the power x. And then they've written it like this, minus of ln of 1 plus e to the power 2x square root minus ln of e to the power x, and ln of e to the power x is x only. So minus minus here will become plus. Yes, they have played a trick in the options. X minus ln of 1 plus, this will become this thing, I wrote incorrectly, ln of 1 plus square root of 1 minus e to the power 2x. Are you getting my point? They've broken this into this form, right? Minus of this minus this. So this will become plus, and ln of e to the power x will be x only. They've used logarithm properties, somewhat of like that. X minus ln of 1 plus square root of 1 minus e to the power 2x. So this is going to be the answer. 1 minus 1 minus 1 minus, not this. This x minus 1 minus ln of e to the power 2x. Oh, sorry. 1 plus. Yeah, all options. Here 1 plus is there, no? 1 plus we need. Correct. We need 1 plus. Sir, mic issue. Studios. Is there a mic issue? Let me check. Hello, hello. Hello, hello. No, there is, the mic is correct. The sound is perfect. Okay, Thakur Shank. Good publicity. I hope you are getting paid for this. If not, then don't waste time. Huh. Here there is a summary of what we have done, and if we solve, we'll come to this conclusion, and we should remember this conclusion. If you see f of x and in the numerator you have f dash of x, if you have a function and in the numerator you have its different derivative, then directly you can write the answer as ln of f of x plus c. Instead of solving, directly you can write the answer as ln of f of x plus c. We have done this so many times, right? If we have quadratic and differential of quadratic in the numerator, then directly we'll be writing ln of f of x plus c. So these are for direct answer writing. right? If you have f of f of x to the power n, and you also have the differential of or derivative of f of x multiplied with it, right? Then you can directly write f of x to the power of n plus 1 divided by n plus 1 plus c. This will be written like this. Direct solution, right? If you have root of f of x and in the numerator you have derivative of this f of x, then your answer will be 2 times of root of f of x plus c. Direct answer. Remember this. Right? We have done this so many times. Suppose you have 2x plus 1 in the numerator and in the denominator you have 2x square plus x plus 3. Then you can directly write ln of 2x square plus x plus 3 whatever, right, plus c. Because you'll put that as t, then t dt you'll do instead of that directly. If you remember, that will be helpful for you and faster. Remember this. Okay. Now some more formats. Format number 2. Over here, what do we see? Either we have quadratic upon quadratic or quadratic upon root quadratic. Also write quadratic, that means ax square plus bx plus c, or square root of px square plus qx plus r. This will work on both of the things. Quadratic upon quadratic, actually you won't need it, but if you have, then also what you have to do, the same thing only you'll have to do. You have to express your quadratic like this. Lambda, this should be expressed like this. Lambda into same quadratic plus mu into derivative of this quadratic plus some constant gamma. We'll understand this with the help of questions, but with the help of, this is how you are going to represent. How? If you have either quadratic upon quadratic or quadratic upon square root of quadratic, this will work in these cases. This format, if you have, what you are supposed to do, you take this numerator quadratic and represent it like this. Lambda into same quadratic in the denominator plus mu into derivative of this quadratic plus some constant gamma, and find lambda, mu and gamma, and then write it in this form, and that will help you solve the problem. How it will help you, we'll see with the help of an example. Here we have quadratic upon root quadratic. Now what is our purpose? We'll try to write our 2x square minus 5x plus 4 in the terms of lambda into same quadratic, that means x square plus x plus 1 plus mu into derivative of this quadratic, that means 2x plus 1 plus some constant gamma. This is what we are going to do if we have quadratic upon quadratic or quadratic upon root quadratic, and this is not going to be very time taking. This is going to be easy only. For example, over here, coefficient of x square, if you compare the coefficient of x square is 2, and here coefficient of x square is only lambda, so lambda is equal to 2. You directly found lambda. Coefficient of x, that is minus 5. On this side, coefficient of x will be lambda plus 2 mu. So lambda plus 2 times of mu. That means your minus 5 will be equal to 2 plus 2, that means 4. Hey, wait. Minus 5 is equals to lambda plus 2 times mu, correct? Yeah. Lambda plus 2 times mu. So your mu is, acha, minus 5 is also there, kya? Lambda plus, so 2 plus 2, 2 plus 2 mu. Sorry, just a minute. Wait. We have done something wrong. This will be solved like this. Minus 5 is equal to 2 plus 2 mu. That means your mu will be minus 5 minus 2 minus 7 by 2. This will be your mu. Easily we have found minus 7 by 2. And similarly you can find gamma also. So 4 will become equal to lambda plus mu plus gamma. Simply your 4, this 4 will become equal to lambda plus mu plus gamma. Constant, this side constant is 4, this side constant will be lambda plus mu plus gamma. So lambda plus mu we know, lambda is 2 and mu is minus 7 by 2. So 2 minus 7 by 2, that means 4 minus 7 minus 3 by 2. 4 plus 3 by 2. Your gamma will come out to be 4 plus 3 by 2. That means 11 by 2. Gamma will be 11 by 2. Check once. Gamma will come out to be 11 by 2. So how easily we'll be able to find lambda, mu and gamma. And now we have to represent this quadratic like this. So our integral will become 2x square minus 5x plus 4 written in this form. What is lambda? Lambda is 2. So 2 times of x square plus x plus 1. This is same only. Don't think we are writing something else. We are writing this in these terms. That's it. So 2 times of x square plus x plus 1. Correct? Minus, oh sorry, plus mu. Mu means, what is that mu? Minus 7 by 2. So minus 7 by 2 into 2x plus 1 minus, oh sorry, plus 11 by 2. Plus 11 by 2 divided by square root of x square plus x plus 1. This is what we are going to do. So our integral will become integral of 2 times of x square plus x plus 1 divided by square root of x square plus x plus 1. Correct? Minus 7 by 2 times of 2x plus 1 divided by square root of x plus 11 by 2 into d into 1 by square x square plus x plus 1. It is going to be time taking, but this is the way. This is the way. And now after this also it's not solved. You'll have to solve it. You'll have to solve it. Others, but now you know the steps. Now you know the steps. This you can solve by square completion, right? You will complete the square in the denominator. 1 by square root a square plus x square or a square minus x square will be created. This you know. Format number 2 or format number 1. Correct? Linear by square root quadratic, right? So this you'll put as t and you'll be able to solve it. This is your, this will just become your 2 into x square plus x, no, 2 into x root of x square plus x plus 1. Just a minute. Yeah, this will become, this is also a known format. Linear by square root quadratic, put this equal to t and you'll be able to find this. Format 2. Format 1 only, right? Linear by quadratic or linear by square root quadratic. Here, what will you do over here? This is a by root a form, na? I mean like x by root x, correct? This is also known. This is also not new to us. 2 by x square plus x plus 1 integral of 2, sorry, just a minute. 2 times of x square plus x plus 1 upon square root of x square plus x plus 1. What is this? This is nothing but a by root a. That means a root a divided by a. That means root a only. So this is square root of x square plus x plus 1 only. A by root a is root a only, na? Think about it. A by root a is root a only. And here you can complete the square very easily, right? This will become 2 times of square root of uh, x plus 1 by 2 plus root 3 by 2. X plus 1 by 2 do it in the x plus 1 by 2 whole square. Let's remove this 2 for now. Just solving this much. Okay, x plus 1 by 2 whole square plus root 3 by 2 whole square. And this format we know, root of a square plus x square, root of x square plus a square. This format we already know. 1 by 2, this will become 1 by 2 times of a, that means 1 by 2 times of root 3 by 2 into ln of square root, ln of x plus 1 by 2. So x plus a will become this thing only. Right, ln of x, that means x plus 1 by 2 plus a. What is your x plus x plus a? That means this thing only. Root of x plus a, that means this. Either you can write this or same thing, x square plus x plus 1. Solve on your own. That is going to be helpful. That is going to be better. Solve on your own. Because you have to save the time, and you can also solve with practice, with the calculation. You will also understand more things. You will also need the formulas if you are reading this for the first time. But you know, after this you can solve. After this you know how to solve. So in this session we are only learning the formats, the general formats that we are needing, that we will be needing to solve the problems. Too long. Solution you can check if you want. Solution you'll be able to check. Now the third format. Third format tells us that if you have cubic upon quadratic, or degree 4 upon quadratic, or some quadratic upon quadratic only. Let's say we have quadratic upon quadratic only. This will also work upon quadratic upon quadratic. It is saying that p of x upon some quadratic, where p of x is either, p of x has its degree either equal to 2 or greater than 2. So basically quadratic upon quadratic is not a format. It's going to be solved with this only. In this case, we'll use the division algorithm. If we have cubic upon quadratic, or degree 4 upon quadratic, degree 5 upon quadratic, in this case, best strategy, or the simplest, or the simply go ahead strategy is your division algorithm. Divide the polynomials and then integrate, right? We use above strategy when degree of numerator is greater than or equal to the degree of denominator. So quadratic upon quadratic also it will work, right? It will work on quadratic upon quadratic also. In case of quadratic upon quadratic, I must tell you, most of the times factors will get cancelled. So don't worry about quadratic upon quadratic, right? Cubic upon quadratic, linear upon quadratic, these are the major cases. For example, this one, we have cubic upon quadratic. Divide the polynomial and try to see what happens. Take a minute, I'll just come back. Yeah, you'll divide this particular polynomial by this and write it in with the division algorithm, that is a is equal to bq plus r, or dividend is equal to divisor into quotient plus remainder. That thing you'll have to represent this into. So let's divide this somewhere over here. X cube plus x square plus x plus 3 divided by x square minus x minus 2. Okay, just divide it with the both of the polynomials. You'll have to divide. हाँ, माइक इशू नहीं है, वो पहले था. Okay, divide it, divide the two polynomials. So x square here will multiply with x. What will come? x cube will come, x cube will get cancelled, minus x square, minus 2x square plus 3x, correct, plus 3, so plus 2, 2x square minus 2x minus 4, that means this will get cancelled, this will become 5x, this will become 7, 5x plus 7, is that correct? So now we can represent this like this, x square minus x minus 2 into x plus 2, x square minus x minus 2 into x plus 2, right, plus 5x plus 7, plus 5x plus 7 will represent the numerator polynomial in terms of division algorithm. That's it. Dividend is equal to divisor into quotient plus remainder. Now, how is this going to help us? As soon as we do this, see, this will become x square minus x minus 2 into x plus 2 plus 5x plus 7 divided by x square minus x minus 2, correct? Now we can break this. This will become integral of, this will get cancelled in the first term, so x plus 2 divide, that's it, x plus 2 dx plus this divided by this, that means integral of 5x plus 7 divided by x square minus x. We know both of these things. Integral of this, writing integral of this is very easy, x square plus x square by 2 plus 2, correct? This format we know, linear by quadratic. We'll represent the above polynomial as lambda into 2x minus 1 plus mu, right? And then we'll be able to solve. Please solve this on your own once. Formats I'm teaching you, but format application please try to do on your own, because I also cannot teach for longer than 3 to 4 hours. My health is also a bit down. If you face any problem in solving these, or if any answer is coming wrong, put that in the comments. I'll take that separately once again. This is linear by quadratic. We have learned. In linear, you'll have to represent in the form lambda into 2x minus 1, lambda into derivative of denominator plus mu. Find lambda and mu and write, and then continue solving. Okay. Now, format number 4. Whenever you have quadratic even powers, right? Even powers. For example, x square plus a square, and here also even power. Numerator and denominator both are having even power. Even power mean power can be also 0. And here power 4. Power can be x square, power 4. Power, this can be x square minus a square or power 4, or x square plus a square by power 4. Even power format, that means numerator and denominator both have even powers. Okay, in that case there is nothing much to do, just divide your numerator and denominator by x square. Divide your numerator and denominator by x square. How will it help? See, numerator will become your, just a minute, your numerator will become 1 plus a square by x square, or 1 plus 1 by x square, right? And its derivative is, its derivative of x minus 1 by x is also 1 minus 1 by x square, right? Derivative of x plus 1 by x is 1 minus 1 by x square, and derivative of x minus 1 by x is 1 plus 1 by x square. So in denominator it will be created, which you can substitute and solve your problem. So this is your format number 4. And one more thing which you can use is here, okay, let's understand it with the help of problem only. That will be a better analyzation. I'll tell you how is this going to help you. Suppose this is your problem, right? Quadratic, and here degree 4, even powers, both numerator and denominator have even powers. What is our strategy? Divide by x square. So only your numerator become numerator. What will your numerator become? Numerator will become 1 by 1 by x square. Sorry, this will become 1 minus 1 by x square, correct? It will become 1 minus 1 by x square. And denominator, what will denominator become? X square. Both numerator and denominator we are dividing by x square, so x square eliminated, cancelled. This will become x square plus 1 by x square plus 1. X square plus 1 by x square plus 1. Correct, isn't it? Dx. Now, there is a relation between this and this. Can you see? X square plus 1 by x square can be written in terms of x plus 1 by x, right? Can be written in terms of x plus 1 by x. Your x square plus 1 by x square is nothing but x plus 1 by x whole square minus 2. Okay. Now keep watching. Now this x plus 1 by x you can put as t, because 1 upon x 1 plus 1 by x, sorry, 1 minus 1 by x square, you will be able to substitute very easily. Just a minute. Now see, your x square plus 1 by x square can be written like this. Now here only, if you put x plus 1 by x as t, you know what is its derivative? It will be 1 minus 1 by x square. Correct? Dx will become dt. Simple substitution will help you over here. You will put this, you will derivate this, 1 minus 1 by x square will come automatically. 1 minus 1 by x square dx will become dt. So this problem became nothing but dt divided by, now x square plus 1 by x square is x plus 1 by x whole square minus 2. So t square minus 2 plus 1. T square minus 2 plus 1, or you can just simply write dt by t square minus 1. And this you know. 1 by 2 ln of, this will become 1 by 2, this is the standard format, ln of t minus 1 upon t plus 1. So whenever you see even powers in the numerator and denominator, directly divide by x square and then substitute like this, exactly like this. Okay, use this and this, both of them. Use this and this. That is going to help you. Try this one. Now here we cannot divide by x square because there is no, although even power x to the power 0 is there, we could do 2 by x square, but here 1 by x square, sorry, x square plus 1 by x square will be created. Correct? Not a problem. But where will this x square go, which is in the denominator? So in this case, when you have a constant in the numerator, you'll have to create x square term over here. You can simply create by writing, oh sorry, this can be done by writing 2 can be written as x square minus 1 plus x square plus 1. Oh sorry, 1 plus x square plus 1 minus x square. Simply do 1 plus x square plus 1 minus x square. You can do this. No problem. Upon 1 plus x to the power 4 in this case. Correct? Here, this entire thing dx. Oh my god, this entire wire I have to keep roaming, otherwise this will get tangled only. Just a minute. Sorry. Now do you see some solution? Right? Simple. 1 plus x square separately divided by 1 plus x to the power 4 plus 1 minus x square separately divided by 1 plus x to the power 4. Now you can apply the same method. Correct? Let's say this part, both the parts we can solve. Both the parts will be able to solve. This one if we solve, divide by x square. So this will become, divide numerator and denominator both by x square again. What will this become? This will become x square plus 1 by x square. Oh sorry, no. 1 plus 1 by x square. 1 plus 1 by x square. What will this become? Divide by x square. So x square plus 1 by x square. This will become x square plus 1 by x square. Correct. Now what do you need in the numerator? You need 1 plus 1 by x square. So what should you put equal to t? Because its derivative should be equal to 1 plus 1 by x square. So put x minus 1 by x equal to t. Right? And when you derivate it, both sides, 1 plus 1 by x square will be equal to dx will be equal to dt. This is an important step over here. Okay, this is very important. What to put as t? If you have 1, if you had 1 minus 1 by x square, you'll put 1 plus 1 by x as t. If you have 1 plus 1 by x square, then put 1 minus 1 by x as t, so that it can give you this. Now this will become this will simply become derivative of what did we, yeah, this is dx, right? So this is dt. This entire numerator became dt. Denominator x square plus 1 by x square. That means x plus 1 by x, sorry, x minus 1 by x plus 2. X minus 1 by x whole square plus 2. So t square plus, this is nothing but 1 by uh, 1 by, this is square root 2 whole square, no? So 1 by a, that means 1 by square root 2 into tan inverse of x by a, that means t by root 2. This is your answer, plus c. Okay, no, not the complete answer. Not the complete answer. You'll have to solve this also. Same strategy. Same way, you'll have to solve this part also. Same way, solve this part as well. Okay, same way, solve this part as well. Okay, this is only this part's answer. Complete answer is not yet obtained. So plus c, let's not apply over here. Solve this part on your own. Okay, this you know how to solve. This also you can solve. Both the parts you can solve. Integration is solving and time taking. Don't worry about it. It is just like that. Same thing. Quadratic, sorry, quadratic by quadratic. Okay, here also divide by x square in both numerator and denominator. Same strategy. I'm just telling you that specific standard formats and same strategy is going to be used. Do not deviate from the strategy. Just remember where to use what. That's it. So again, we'll divide numerator and denominator by x square. It will become 1 minus 5 by x square. Denominator will become x square plus 1 plus 25 by x square plus 1. That only, right? X square plus 5 by x whole square. Let's write 5 by x whole square. No problem. It's better 5 by x whole square plus 1. Now what to put as t? The question is what to put as t. We'll put, see, what do we need? 1 minus 5 by x whole square. So we'll put x minus, oh sorry, x plus 5 by x as t. So that we get 1 minus 5 by x square dx equal to dt when we will differentiate on both the sides. Now our problem will be solved. Correct? Why? Because see, over here if we'll come, numerator will become what? Numerator will be dt. Denominator, what is t? X plus 5 by x is t. So x plus 5 by x whole square minus 10 plus 1. Correct? X plus 5 by x whole square minus 2. Instead of 2, we'll have 10 because 5 is there. 5 into 2. So x minus, so what we will have? Our x plus 5 by x is equal to t. So what will this become? T square, x square plus 5 by x whole square plus 2 into x into 5 by x, that means 10. Right? So minus 10 we'll have to do. T square minus 10 plus 1. That means t square minus 9, that means 3 square. This we know. 1 by t square minus 3 square will be 1 by a. That means 1 by, oh sorry, wait, 1 by 2. 1 by 2 into ln of t by 3, sorry, wait, I'm also forgetting. T square, a square minus x square minus a square, just now, 1 by 2a. So 1 by 2 into 3, that means 1 by 6 into ln of t minus 3 upon t plus 3. Now t minus 3 upon t plus 3. T minus 3 upon t plus c. This will be your direct answer. Okay. There are some more formats, but I think I'll have to take a pause over here. Or let's because my throat is completely choked, and I think we can take one more class for, because anyway we'll not be able to complete, I'll not be able to complete by parts, partial and trigonometric formats in one go itself, because I think as more I'm speaking, my throat is paining now. I'll have to treat it first very well, and we can take it tomorrow or day after tomorrow, the next part of this session, where we'll be learning partial fractions, different integration of partial fractions, integration by parts, and the trigonometric formats. Till then, you can completely and thoroughly revise these parts also very well. Solve them once or on your own. Integral solutions are very long and time taking. That's why we cannot solve, time and space taking. That is why we might not have solved some of the questions completely, but your job is to solve them completely till the answer. Okay. Remember all the formats as it is. Here also we have some formats. Suppose here, see, phi x represents linear or constant. Phi x means either linear or constant. That means a polynomial which is either linear or it is a constant. Okay. If we have such format, suppose phi x dx we have linear multiplied with square root of linear, or we have quadratic multiplied with square root of linear. For these also we have specific standard methods to apply. But I think, just a minute. Okay, let's try. Let's see that if we can complete this part at least. If I need, I'll take a small break and see if I can, work better. Okay. Now here, whenever you see these type of formats, in denominator, if you see a linear and square root of another linear multiplied, or in denominator, if you see a quadratic and square root of a linear multiplied, and in numerator, you might have a linear or a constant, right? Either a linear or a constant. In this case, there is a specific strategy. What you have to do is, the substitution is specific. In this case, you have to substitute this ax plus b thing as t square, as it is. As soon as you see this, ax plus b means this term, either this term or this term, whatever is inside the square root, that you have to substitute as t square. With this square root linear, a quadratic can be multiplied or another linear can be multiplied. In this case, this thing you have to substitute as t square and then proceed, right? That is a standard specific method that you have to use as it is. Second case, in numerator again linear or constant. In denominator, inside the square root, if you see a quadratic and multiplied with a linear or linear to the power something, right? Linear to the power r, here only linear, right? 1 degree linear. In this case, you'll substitute this px plus q. Every time linear only will substitute. You'll substitute this px plus q as 1 by t. Okay. So first one, that if you see a quadratic multiplied with square root linear, or linear multiplied with square root linear. In this case, whatever is inside the square root, the linear thing, that you substitute as t square. In this case, when you have inside the square root, you have quadratic, and with it, either a linear is multiplied or linear to the power of something is multiplied, then in that case, linear you will substitute as 1 by t, remember them, that will only help you. In this case, whenever inside the square root you have quadratic ax square plus b, and outside also you have the same form px square plus q, same form inside the square root and outside also same forms are available. In this case, simple substitution, just substitute x is equal to 1 by t. Only x you have to substitute, which will be substituted as 1 by t. Okay, as it is these substitutions. I hope it's written here also. In the first part, put ax plus b is equal to t square. In the second part, tx plus q is equal to 1 by t. In the third part, x is equal to 1 by t. Now let's see how is this going to help us. For example, in this question, just try once on your own. Try putting x plus 1 as t square. This is which form? Square root, linear and quadratic is multiplied. So what is the suggestion? X plus 1 as t square. Put x plus 1 as t square and proceed, and I'm sure that you'll be able to solve your problem on your own. And here I'll just need to take a small medicine, so I'll take somewhere around 10 to 15 minutes. Please hold on. If I feel better, then we'll continue the other parts also, partial and all. If not, then we'll continue in the next session. Okay, so I'll write over here, proceed with this one. Okay, start with this one, take x plus 1 as t square. Okay, and